That we showed you, because we have a vast horizon with large mountains and plateaus in the distance. A spectacular place indeed. I'd like to show you, just for comparison, perhaps to look back 20 years to the first time that we land on Mars and show you what a different planet we have now found and what a different surface. The first one, please. Peter, can I have the... This is Viking 1, and for those of you who were at the press conference the first day we were here, you heard me excitedly talk about, if we were to land in a place that looked like this, what great and wondrous things that I thought we could do. We could go over to this outcrop and we could look at these rocks at the edge and look at how boring this spot looks compared to where we landed. Next slide, please. This is Viking 1 in a different direction with the large rock called Big Joe and these aeolian or water-strewn dune fields here. Again, a very different looking place with a remarkably flat horizon at Viking 1, and perhaps even more so at Viking 2, the next one. This was dreadfully, sorry Jerry, dreadfully flat. And we were never in fact able to determine exactly where we came to rest with Viking 2 because there's just about nothing on the horizon here. And you've already seen the spectacular ranges in the distance, and we hope to start looking to those to triangulate to figure out where we are, and we've not done that yet. Second, you probably also heard me get extremely excited about all the things we were going to do with those rocks. And I think you saw how many rocks how many rocks there are in that field, and already the science team is salivating to get their hooks into them. So there are many wondrous things to see in there and wondrous things to go and do, and we hope to start doing them very, very soon. You saw the imager worked flawlessly. The meteorology station is functioning perfectly, although the mast has not yet been deployed. We do not have health data on the APXS yet, but there's no reason to suggest it's anything but fine. All the science instruments are functioning perfectly, and we're very excited to get going. And to give you an idea of what we're going to do next, Brian Muirhead.
Thank you. Well, I think for everyone here at JPL, and I suspect maybe everyone around the world, today's results far exceed our expectations. The flight team is absolutely ecstatic. The morning's activities, the success of the EDL, that was just incredible, and I think Rob and Richard told you that story very well. And of course, our first downlink gave us that first EDL information, but at 4:28, when the high gain came online, was unbelievable for us. Because we, again, know how complicated this machine is, how complicated, what had to work right to get that high gain link there. And there it was, right on schedule. High gain was pointed within 1 degree of the Earth. It was perfect. We don't even test it that well when we do it. I mean, when we do our simulations, and we've done our simulations, they don't begin to compare to the perfection of the way the hardware, the software, and the operations team have worked so far on this activity. It's really, really wonderful. And we're just totally in love with our baby. I do have some stuff I want to show you. I'd like to bring up the first image. Let's see here. There we go. The thing that we're doing right now is and Jake will talk about this in much more detail, is we're assessing the ability to deploy the ramps and deploy the rover. And you can see in this image an airbag in the front side. This is the forward side of the rover. Let me have the next image up, please. Keep going. Keep going. I'm looking for the rear deploy. There we go. Let's try with that one, please. Okay, this image shows the airbag on the rear side. You can see how it's billowed up. That airbag is not fully retracted. We don't quite know why that is, but what we're planning to do, what the flight team is doing right now, is testing a sequence, and may have already even uplinked the sequence that will cause us to, and let me show you with this little model here. Okay, here's the pedal where the rover is on, and what we're going to do is we're going to lift that pedal up about 45 degrees, and then we're going to turn on the actuator that pulls the airbag, that's retracted the airbags, and we're going to turn that on for about 10 minutes and try to pull that airbag in a little bit more and get it down below the pedal. And then we're going to lay that pedal right back down. And we'll get back right to the position we're in. What we're doing right now is testing the sequence that does all that. We test it in the sandbox, and before we uplink it, then we'll uplink it, and then we'll execute that process. Then we'll use our camera again to take the same images, that the first images you saw, that assess the area around the rover, look to see whether that helped us a lot, which we expect it would, and then we'll make the decision about whether to deploy the ramps. I don't know right now when we would see those next images of this area. It's probably no earlier than 7:30, 8 o'clock. Unfortunately, I'm not in communication with the team right now, but that's what we're working on right now. We'll get those airbags retracted. The team will assess the ramp deployment, and then we'll get on with the rest of the mission. But for me, and I know for the rest of the team, this is we've scored a major home run here with this activity so far today. And on that, I'll turn it over to our illustrious rover manager.
Yes, thank you, Brad. Let me just point out a couple of the issues that have arisen as a consequence of our performing the assessment of of this scene from the standpoint of the deployment of the ramps. I'll do that, but first I wanted to extend my own welcome to a friend I haven't seen for well over 9 months now, and that's the Mars Pathfinder rover, Sojourner Truth. Yeah. It looks just wonderful, and in fact, that solar panel is that's the first time I've seen that solar panel. It's been covered every day, and it's been here at JPL and down at the Cape, so it was really very fortunate to actually see this here. But in particular, let me just point to a couple of issues here on the rear ramp deployment. Our concern is this little bit of airbag material that's currently sitting over the edge of the rolled up ramp. Although the picture breaks a little bit there, you can tell that that when the ramp is actually deployed, since the way it deploys, those two strings are broken. The ramp deploys out like a springboard and then falls down. The concern here is that if we tried deploying the rear ramp in this configuration, the edge of that ramp would catch on that airbag material and possibly fall back onto the rover or onto the pedal. So part of the strategy for retracting airbag material, at least from the standpoint of the rear, is to be able to remove a little bit of this material here and allow us to be able to deploy the rear ramp. On the front side, and maybe one of the prior images will show that a little better. If we can go back one or two. Well, maybe I can just describe it here. There's a fair promontory of airbag material out in front of the pedal that anywhere from 7 to maybe 15 centimeters tall above the height of the pedal itself. And again, that poses a kind of similar risk for the ramp deployment. If we tried releasing that ramp, again, the springboard would hit the airbag material first and conceivably could come back, although it depends a little bit on what that airbag is actually sitting on. One thought is that perhaps, there we are, that perhaps this airbag material is actually sitting on top of a rock. As you can see, we're attempting to make some estimates based on the rest of this terrain here. It looks like some fairly good-sized rocks in that area that in fact, that might be one of the reasons why this airbag is sitting where it is. But otherwise, the thought of being able to deploy or remove more of this airbag material, at least reveal what we're sitting on, and conceivably give us a little better clearance for releasing the front ramp. Also, as part of this assessment, we made a preliminary assessment as to where the ramps themselves would fall once they have been released. And in the front, they release somewhere in this area here on the other side of the airbag material. And on the rear, if we go back a couple of frames, I can kind of point out where that is. Okay, maybe there's one more. Yeah, that's fine. We could deploy in this area here with the ramp. Part of what I'm pointing to here is area that we actually have stereo image coverage in this image sequence set. And so as a consequence of that, we are actually taking measurements.
Donna Shirley, as you listen to this with us, give me your thoughts. How serious does this problem appear based on the pictures and based on what you've just heard?
Well, the problem appears that it's something we have to deal with. The rover ramps, we could try to deploy the rover ramps, but the rover team and the pedal team, the mechanical team, and the airbag team have looked at it very, very carefully, and they've concluded that the safe thing to do is to attempt this additional retraction. Now, if the airbags do retract more, and if it turns out that there are rocks under the airbags, it's possible that the ramps could be fairly steep for the rover to go down. So the rover team is currently testing a 9-pound rover here on Earth, which is the same weight as Sojourner is on Mars, to see how steep a ramp it can actually go down. And they feel pretty confident that the rover will be able to go down one way or another any steepness of ramp. So it's a delay, but we never figured that without incredible luck that we would get the rover off on the first day. We were going to try, but if it's the second day or even the third day, it's not a big problem.
Okay, Donna, stay with us. We're going to take a quick local cable break. We'll come back with more of the news conference, more of your expert commentary on it. Stay with CNN.
They are here and in color. The first pictures from the Mars Pathfinder have been sent back to Earth. NASA scientists at the Jet Propulsion Laboratory in Pasadena, California, cheered as the black and white images began appearing about 2.5 hours ago. The first photo showed a small portion of the space probe, one of the deflated airbags used to soften its landing, and several rocks. Later images showed parts of the Sojourner rover, which will be driven off the probe in a few hours. The images will be weaved into a mosaic by a computer, eventually forming a panoramic picture of the Pathfinder and the Martian surface. These are the first images from Mars in more than 20 years. And later in our show, we'll have a report with CNN's John Zarella, who's at NASA's Jet Propulsion Laboratory in Pasadena, California. In what has been described as an extraordinary day, NASA engineers received the first images from Mars in 21 years. The images are one of many of the day's successes. Joining us now from the Jet Propulsion Laboratory in Southern California is CNN's John Zarella. Hello, John.
Hello, Relitza. And those color images that they just released a little while ago, certainly spectacular images of the red planet. In the distance, you can see what could be hills or perhaps mountains. And many, many rocks for the geologists to get a look at when they finally get Sojourner off of the vehicle, which may not come today, probably won't come today now. And joining me to discuss that is Donna Shirley. And Donna, you've been with us all day. And, of course, everything had gone so perfectly well. There had to be a problem of some sort. And what is it? You've got airbags stuck. And on what pedal? The one the rover's on.
Right, absolutely. Of course, the great galactic ghoul had to get us one way or another. Well, if we can look at the model here, Sojourner is on this west-facing pedal. This is west on Mars. The sun in these pictures is coming this way because it's morning, and these airbags are wrinkled up like this around the pedal, such that the ramps, as they have to unroll to let the rover off, could possibly have a problem. So what they're doing right as we speak is they're tilting the airbags up to tilting the pedal up to 45 degrees. They'll pull the airbags in some more, and then they'll put the pedal back down, and then they'll take some more pictures to see if the ramps can now be unrolled safely.
And, of course, what just happened with our little rover won't happen because it is firmly locked on that pedal.
Absolutely. It is still squatted down on the pedal, flat down to the pedal, and it is locked down so well that it was able to take all of that pounding during the landing without coming loose, and it's still locked down.
So chances are then tonight we will not see Sojourner off of the pedal.
Off the pedal. The odds are not looking good.
But we have many days ahead, and perhaps tomorrow will be the day. And things have gone so very, very well that obviously this is a hitch, but it is not a terrible, terrible setback. And if these engineers could get this vehicle to the red planet, there's no doubt they can figure a very good solution to get Sojourner off of the pedal. Ralitza?
Certainly. Thank you very much, John Zarella, in front of Mission Control in Pasadena, California. For 16...
Is CNN's coverage of a live event.
What a day. What a night. What a time to be alive on planet Earth. We sent something to planet Mars today. It is sending back fabulous black and white and color pictures to the Earth. The folks at the Jet Propulsion Laboratory in Pasadena, California, put the project together. And everything has been going swimmingly until about 30 minutes ago, when some of the first pictures that came back showed us something that could be a problem. Maybe not a big problem, we don't know yet, but one of the things that is unique about this mission to planet Mars is that rather than landing on the planet, like most spaceships from Earth do, this one bounced into the side of the planet inside a giant beach ball made up of dozens of individual airbags. What was supposed to happen when the Pathfinder landed on Mars was that these airbags were supposed to retract underneath the Pathfinder and sort of look like that tannish mush that you see there below the solar panels on your screen in this animation. That's not precisely what happened. And as a result, what you just saw in the animation is not going to happen tonight. This is a picture that came down from Mars just a few minutes ago. Instead of being underneath and out of the way of the Sojourner rover, you can see that big tannish airbag is blocking the exit from the Pathfinder of the rover. And it looks like it's even possible that a piece of that airbag might be somehow connected to the ramp. The things that look like rolled up duffel bags are in fact the ramps that Sojourner will use. This is what NASA wants to do to fix this problem. Even though all three solar panels, which are called petals, like flower petals, were flat and parallel to the ground, the one where the airbags aren't fully retracted will be raised to a 45-degree angle. And then the automatic retraction system for the airbags will be told to come back on and retract those airbags some more. If it works, the airbags will be sucked in as if vacuumed up underneath the Pathfinder, and then that pedal with the rover on it will lower itself again back down to a level that's parallel to the ground. The two ramps on either side will roll out, and then the rover will go out and do its job. It was hoped that that would all happen about 88 minutes from now, but that's not going to be possible because of the problem with the airbags. They're still scratching their heads in Mission Control, trying to figure out exactly the best way to do this. And so that's going to delay the first movement out on the surface of Mars of that rover. My colleague John Zarella has been doing yeoman's work for the past 6-7 days out there at the Jet Propulsion Lab. Oh, buddy, you must be tired at the end of this long day, but isn't it satisfying?
I'm telling you, John, even standing up for 6 or 7 hours today, it doesn't seem to bother me at all. This has been quite an adventure tonight. Isn't it a shame that the only pedal that these airbags happen to be in a bad position on is the pedal that is containing the Sojourner rover on it? So that was a bit of bad luck, but after so much sensational, absolute near perfection all day, it is certainly something that's an acceptable problem that they will, I'm sure, deal with. They're going through the motions now to try and figure out exactly how they're going to handle this and get that airbag retracted so that they can get Sojourner off. And as you said, it'll probably be tomorrow. And joining us here tonight is Story Musgrave. And Story, you haven't been to Mars yet, but an astronaut for many, many years. You've flown in space probably as much, if not more, than just about anybody out there. And what was your feeling as you were seeing these pictures of Mars? I know that every astronaut would love to be the first to put his or her foot down on the red planet.
Well, I've dreamed. My imagination has taken me out there, John. The call is there. It beckons. The beauty of the place, it really does call. And with a brand new technology, with a very efficient small satellite that it came just scooting and screaming out in there, and it's there, it lets you know how doable the whole thing is. But it's like a stepping stone. We go from Earth to Mars, and away we go.
What did you think as you saw those first pictures? The black and whites came out first and gave us some really tremendous images. There's some there we can take a look at right there what that looked like. Those were the first black and whites several hours ago now. What were you thinking when you were seeing those?
It's just stunning, and you flash back to Viking, and you think of we've returned to an old friend after 20 years. But the call is there. I mean, you just see it and you feel the pull.
Are you amazed at the clarity of the images and exactly the nature of the landscape? It seems to be quite a bit, and that's a rover wheel that we're seeing in that picture. But the landscape seems to be quite a bit different than what we saw on the Viking missions.
Bigger rocks, but still friendly. Still an incredibly friendly place. We just need a little bit of water.
And that's probably buried beneath the surface in permafrost.
Find out where the water went.
So these first exploratory missions that we're doing, any doubt in your mind, you say the call is there.
The call is there.
Any doubt in your mind when we see things like this after 21 years now that it's going to re-energize an effort to send humans to Mars, do you think?
No doubt. And the visual data is extraordinarily important. The scientific data is too. The spectrometry data will be incredibly important.
Here's the sandbox. Now look, we're actually seeing them doing the test to see if at how steep an angle they can get the rover off of one of the pedals. And that would be a rover coming down the pedal and into the sand, and they're... Now a lot of these kinds of things are not foreign to you, certainly, because they did many of these things within the human space program.
That's testing that simulation, and that's a playground, and it's incredibly useful to not theorize as to how things are going, but to go out there and to mimic and to set up the scenario and to run it for real.
Now, in a more, certainly a situation that was far more potentially dangerous, that's what they did during Apollo 13. They ran simulations.
Yes.
How could they get things fixed? So they're basically, here we are many years later, but doing similar things.
If the fidelity of your training and your simulation devices are good enough, when you need to test how it's going to go up there, you can do it on the ground.
Let's take another look at some of the black and white photographs that we have earlier today. Oh, we're back in the sandbox, so they are still... They're really looking now at, from what I understand, the angles, so that they can see that how much of an angle is going to be too much of an angle to get the Sojourner off, if that's what they end up with, a real steep angle once they bring the airbag in. So I assume that's what they're working with, to see how much they can have to play with. Is that what it appears to you?
I'm not an expert in that area.
This is what I had heard earlier from one of the engineers, that they were really concerned about what the angle might be once the airbags were retracted, if the pedal actually went down many more degrees than it is now. That would present a much more steeper angle when they unfurl the pedal there. So again, they're still playing in the sandbox, as you said, and trying to figure out the best. This could go for quite a while, I would assume.
Story, you mentioned earlier, this is John Holloman, that simulation and training and practice is the key to success. I saw some pictures today in a water tank in Russia of a couple of cosmonauts in spacesuits, and they are beginning to simulate that internal spacewalk that's going to have to take place on Mir. Now they're saying they can't do it before the 17th or 18th of July at the earliest, because they want to give the cosmonauts in space time to practice, and they want to give these cosmonauts in the water tank in Russia a chance to see what's going to happen when they get in this very cramped quarters. You and I have talked on the phone several times about what ought to happen in a well-planned spacewalk to fix the problems on Mir, and we should let our viewers know in about 90 minutes from now, the Progress resupply vehicle with the repair parts for Mir is scheduled to blast off from the Baikonur Cosmodrome. We plan to have live coverage of that. So just, given those circumstances, let's talk about the value of simulation for the spacewalk on Mir. And have you heard any more about how that might work than when we talked the last time?
We sure are having a huge space day with a joint mission up there, the practice on the ground, and SDS-94 up there, and a Pathfinder landing.
These are the pictures from Russia today, by the way, of the cosmonauts in the water tank doing their simulation.
I have always emphasized that in close quarters you need to do more water tank choreography than in any other condition. When you have to take your body and fit yourself into very close quarters, it's like a three-dimensional jigsaw puzzle as to how you're going to get in there, and especially if you have to get in there and maneuver equipment in and out of closed spaces.
Now that pretty much is the Spectre modules being simulated underwater there, which the cosmonauts are going to have to go into on the 17th or 18th. Story, we need to go ahead, jump in.
And water is the place to do that. And the next thing to do is, once you've worked it out on the water, how do you communicate to the people on board your geometric experiences? And so that's an art form in itself, how you get the geometric experience here to them.
Right, because these cosmonauts have never put on two spacesuits inside their space station and tried to do work inside. They've been in an airlock on the way to do an outside spacewalk. We're going to take a quick break. Story Musgrave, John Zarella, it's good to see both of you and that you're both holding up on this most fabulous day in space and back here on Earth, because we're getting to look at it. Stay with CNN. We'll be right back. NASA engineers at the Jet Propulsion Laboratory getting very excited about the fact that they were able to do something they have been working on, most of them, for more than 5 years. That is taking a $100 million, just a little bit bigger than a shoebox-sized rover, and plant it successfully on the surface of planet Mars. What a moment for these people. This is the live picture in Mission Control now. They have had a long day. It is 7:44 in the evening at the Jet Propulsion Laboratory in California, and they have been there putting in a very full day, controlling this mission from the ground, but mostly, based on what we've been told, just letting the Pathfinder do its own thing. It has a computer on board that has been doing everything just like clockwork. One little problem. CNN's John Zarella joins us from the Jet Propulsion Laboratory to talk about that and what kind of day this has been. John?
Well, I tell you, John, that, I think back it was December 4th when they lifted off from the Kennedy Space Center very early in the morning, a rather chilly night even for Florida back then, and here they are 6 months later to the day, and they're on Mars. And I remember interviewing Brian Muirhead, who's the deputy project manager, in the clean room a month before that, wearing our white bunny suits, and Brian saying, nobody would have given us half a chance of getting as far as we are today, and that was just getting to the clean room. And here they are now on Mars. We've had fabulous black and white images. We've had fabulous color images back from the red planet, and they've run into the one snag that they've got to work around. And there are those black and white images. The Story Musgrave, you're with us here, and we were talking about how that's an airbag there in the foreground. We were talking about how these things are tested and retested, and how now when they run into a problem, they'll go into the simulator to figure out. And you did that with the Hubble repair mission. You had to do tremendous simulations, didn't you?
It's basically play with physical things as opposed to speculate and guess. And that's what they're up to.
These, you were saying, now there are a lot of rocks there, but again, that's quite a bit more in the way of what I thought. I didn't think there would be as many of the large boulders that there appear to be, and in the distance hills, and it's a different topography.
You have to ask them, but maybe they didn't guess to have quite that much in the water outflow.
And there's what appears to be one of those hills in the distance. And again, this is supposed to be an ancient river, an ancient outflow where a tremendous flood eons ago swept down through here, left and deposited rocks and all kinds of goodies for the geologists to get a look at. So it really is critical, isn't it, that they get Pathfinder's Sojourner robot off of the vehicle so they can start getting up to rocks like that and studying them.
And doing the soil itself.
And the soil itself. What will they learn, do you think? What are they going to be able to find out?
They're going to learn the chemistry, John. The spectrometer will give us the chemistry of Mars.
Fellas, can I interrupt for a second? John. We just got word that a different sequence of photographs from the surface of Mars is about to be coming in to Jet Propulsion Lab Mission Control there in California. We're going to watch those pictures as they come in, I would reckon. And as we continue to look at the pictures that came down a couple of hours ago, until we get the new pictures, let's go back and look at the old ones. Some of our viewers have called and asked about the shape of some of the rocks. Now, not in this picture, those rocks look like rocks, but there are some that we have seen throughout the evening that look almost as if they might have been carved. I mean, they have very straight curves on the corners. And as we look at that, I'd like you, Story, because you've got a certain interest, a great interest in geology, to tell me how that could come about. If we can, I don't know if we can find one of those pictures while you're looking at it, but I've seen several tonight that look sort of like they've been cut pieces of stone. How would that occur naturally on Mars?
And I agree with you very much, John. They look fractured. They look almost as if something broke the rocks, and then after the breaking, there was minimum erosion to round off the corners.
I guess that tells you a little bit about the winds and the sandstorms and things on the surface of Mars. Probably hadn't been much windstorm or sandstorm action on those rocks to keep the sides of them as smooth as they are.
Or it's fairly recent.
Yeah, that's a good point. And we're going to learn, I guess, a good bit about the age of these river valleys as soon as we can get a sample of this stuff from the surface of Mars back to Earth, so that we can do some sort of dating on it. Maybe carbon dating would work on samples of Martian soil and the pieces that'll come back. I was asking Donna Shirley and a couple of other people earlier today how long ago this river basin had water in it. She said, don't have a clue, won't have a clue till we get some of this stuff back on Earth and can analyze it. But there are some of these rocks that seem to have fairly square corners. This is just fascinating to look at, to me, Story.
It sure is. It's amazing the diversity that you get in planets that all got formed in the solar system, depending upon where they got formed, what their orbital mechanics, how far out they are, what their rotations are, and what their chemistry was.
You know, Story, some of those look almost as what you'd see out in the west out here in the United States, where you have the great rivers that carved these canyons through there, and they really smooth them out over the eons of time.
Very familiar territory.
Story Musgrave, I'm told that the day you came to work for NASA, at the end of the Apollo days, it was your assumption you were going to be the first human being to walk on Mars. Is that true?
I thought we would have been there in 30 or 35 years, and with the acceleration in technology that we had, I think it was reasonable to expect that within 30 or 35 years we would be there, and I was a long-term investor.
Yeah.
And I was interested in life out there and in medicine.
Well, you know, your life's not over yet. How old are you today?
I'm going on 62 next month.
All right. Well, see, I mean, you got time, and you're a young 62. We got to take a quick break, Story. We'll be back with you and John Zarella, the rest of our crew. What a day this has been. To all our viewers who are sending us email and calling us up to ask questions of our guests, thank you all for being with us today. Big day for CNN. This is a live picture from inside NASA's Mission Control at the Jet Propulsion Laboratory, where new pictures from the surface of planet Mars, the second series of post-landing pictures for the Pathfinder probe, are beginning to be presented to the experts there. They're going to look very similar to the pictures we have seen over the past 4 hours, but the sun angle will be different because the sun has shifted in the sky. People all over the world are participating in our coverage tonight, watching these live pictures from Mars all over the place. At Planet Hollywood in Washington, the National Space Society put together a big wing-ding. Education Director Carolyn Josephs joins us now. Carolyn, I have a 4-year-old, and I know a lot of children who are in the 5 to 10-year-old age group who have seen these pictures tonight and really been knocked down by them. Is this going to help stimulate interest in space science, do you think?
I hope so.
Yep. What do you think the offshoot of this might be as the education director of the Space Society? There are people who've created CD-ROM programs to show people animations of these various things. Is this going to be a good thing?
I think it is. Our chapter does too.
Yeah, okay, Carolyn. Thanks very much for joining us. Looks like a big party there at Planet Hollywood in Washington. All right, back to Pasadena. Story Musgrave, John Zarella. More pictures will begin coming down pretty soon. We're going to compile them here. If they look remarkably different from the pictures we have seen before, we will pop in and share them with our viewers. Just a remarkable night. Yeah.
We may, John, have some photos that'll give us an idea whether they were able to retract the airbags if they performed that maneuver, because there was some talk that they were uplinking the commands to the vehicle not long ago, so it's certainly possible.
Yeah, I think that's what I am hearing in my ear, John, that these pictures will show whether they've been successful in getting this thing ready to get the rover off. But so much has to be just right for this to happen. The rover on Mars has to be able to see the Earth. The sun has to be up to charge the solar panels. So it's a very complicated thing. We've only got a couple minutes left in our live programming here. Story Musgrave, you got any final thoughts before we sign off here tonight about the meaning of this, sending unmanned robots to Mars and the prospect of having human beings, you or me or my 4-year-old Jay, walking around up there someday?
Well, John, when he landed on the moon, I was in mission control, and after the dust had settled, so to speak, I had to go outside and look up and take a look at the moon. The moon had new meaning, and what it was to be human had new meaning, and I have not looked into where Mars is tonight, but I will look into that, and hopefully it'll be visible tonight or tomorrow morning to go out there and take a look at that planet and realize that we are there and that the quest continues.
All right, it's on the west side. Look to the west, just above the horizon. It might have already set for the night, but you'll be able to see it just around sundown tomorrow. That's all over the United States, I'm told. John Zarella, you come back to me before in our final minutes here and give me your final thoughts on this. What a day. What a day of remarkable information and visual information.
And you know, it's one of those days where the hours just click by so quickly because one event after the other, starting very early this morning, was happening here with the descent through the atmosphere and this very 4.5 minutes of just one pyrotechnic event after the other having to take place perfectly for this to work, and everything did. John?
John Zarella, thank you very much. And to our hundreds of viewers, we have gotten more phone calls today from people watching this on television wanting to know more. Thank you for participating in our live coverage. For the whole CNN team, John Holland, good night. Thanks for being with us.
They are here and in color. The first pictures from the Mars Pathfinder have been sent back to Earth. NASA scientists at the Jet Propulsion Laboratory in Pasadena, California, cheered as the black and white images began appearing about 2.5 hours ago. The first photo showed a small portion of the space probe, one of the deflated airbags used to soften its landing, and several rocks. Later images showed parts of the Sojourner rover, which will be driven off the probe in a few hours. The images will be weaved into a mosaic by a computer, eventually forming a panoramic picture of the Pathfinder and the Martian surface. These are the first images from Mars in more than 20 years. And later in our show, we'll have a report with CNN's John Zarella, who's at NASA's Jet Propulsion Laboratory in Pasadena, California. In what has been described as an extraordinary day, NASA engineers received the first images from Mars in 21 years. The images are one of many of the day's successes. Joining us now from the Jet Propulsion Laboratory in Southern California is CNN's John Zarella. Hello, John.
Hello, Relitza. And those color images that they just released a little while ago, certainly spectacular images of the red planet. In the distance, you can see what could be hills or perhaps mountains, and many, many rocks for the geologists to get a look at when they finally get Sojourner off of the vehicle, which may not come today, probably won't come today now. And joining me to discuss that is Donna Shirley, and Donna's been with us all day. And of course, everything had gone so perfectly well. There had to be a problem of some sort, and what is it? You've got airbags stuck, and on what pedal? The one the rover's on.
Right, absolutely. Of course, the great galactic ghoul had to get us one way or another. Well, if we can look at the model here, Sojourner is on this west-facing pedal. This is west on Mars. The sun in these pictures is coming this way because it's morning, and these airbags are wrinkled up like this around the pedal, such that the ramps, as they have to unroll to let the rover off, could possibly have a problem. So what they're doing right as we speak is they're tilting the airbags up to 45, tilting the pedal up to 45 degrees. They'll pull the airbags in some more, and then they'll put the pedal back down, and then they'll take some more pictures to see if the ramps can now be unrolled safely.
And of course, what just happened with our little rover won't happen because it is firmly locked on that pedal.
Absolutely. It is still squatted down on the pedal, flat down to the pedal, and it is locked down so well that it was able to take all of that pounding during the landing without coming loose, and it's still locked down.
So chances are then tonight we will not see Sojourner off of the pedal.
Off the pedal. The odds are not looking good.
But we have many days ahead, and perhaps tomorrow will be the day. And things have gone so very, very well that obviously this is a hitch, but it is not a terrible, terrible setback. And if these engineers could get this vehicle to the Red Planet, there's no doubt they can figure a very good solution to get Sojourner off of the pedal. Ralitza?
Certainly. Thank you very much, John Zarella, in front of Mission Control in Pasadena, California. To cheer at NASA's Jet Propulsion Lab as the Pathfinder beams down its first images of Mars. In what has been described as an extraordinary day, NASA engineers received the first images from Mars in 21 years. The images are one of many of the day's successes. Joining us now from the Jet Propulsion Laboratory in Southern California is CNN's John Zarella. Hello, John.
Hello, Ralitza. And those color images that they just released a little while ago, certainly spectacular images of the red planet. In the distance, you can see what could be hills or perhaps mountains, and many, many rocks for the geologists to get a look at when they finally get Sojourner off of the vehicle, which may not come today, probably won't come today now. And joining me to discuss that is Donna Shirley, and Donna's been with us all day. And of course, everything had gone so perfectly well. There had to be a problem of some sort, and what is it? You've got airbags stuck, and on what pedal? The one the rover's on.
Right, absolutely. Of course, the great galactic ghoul had to get us one way or another. Well, if we can look at the model here, Sojourner is on this west-facing pedal. This is west on Mars. The sun in these pictures is coming this way because it's morning, and these airbags are wrinkled up like this around the pedal, such that the ramps, as they have to unroll to let the rover off, could possibly have a problem. So what they're doing right as we speak is they're tilting the airbags up to 45, tilting the pedal up to 45 degrees. They'll pull the airbags in some more, and then they'll put the pedal back down, and then they'll take some more pictures to see if the ramps can now be unrolled safely.
And of course, what just happened with our little rover won't happen because it is firmly locked on that pedal.
Absolutely. It is still squatted down on the pedal, flat down to the pedal, and it is locked down so well that it was able to take all of that pounding during the landing without coming loose, and it's still locked down.
So chances are then tonight we will not see Sojourner off of the pedal.
Off the pedal. The odds are not looking good.
But we have many days ahead, and perhaps tomorrow will be the day. And things have gone so very, very well that obviously this is a hitch, but it is not a terrible, terrible setback. And if these engineers could get this vehicle to the Red Planet, there's no doubt they can figure a very good solution to get Sojourner off of the pedal. Ralitza?
Certainly. Thank you very much, John Zarella, in front of Mission Control in Pasadena, California.
Reviews back on Earth. The Mars Pathfinder mission got off to a successful start on Friday when the space probe landed on the Red Planet. These are some of the first pictures from Mars in more than 2 decades. They were taken at a Martian surface temperature of -53°C. They show part of the Sojourner rover, airbags used to cushion its landing, and rocky terrain beyond. They also show a partially deflated airbag, which must now be fully deflated to clear a path for the Sojourner. If that can be done, the rover will leave the safety of its landing craft. It's designed to move around the surface of Mars for a week, looking at and testing everything in its path.
We have
NASA scientists at the Jet Propulsion Laboratory in Southern California cheered when the first pictures began appearing. It's being described by the space agency as an extraordinary day.
The little engine that could did, and we are just absolutely boggled by the fact that this fairly complex design that we've been thinking about and stewing over and testing and trying to make work really did the job.
Images being sent back to Earth are to be merged into a mosaic by a computer, eventually forming a panoramic picture of the Pathfinder and the Martian surface. Well, Mars has fascinated people for centuries, and Pathfinder's mission is likely to enhance the intrigue. CNN's John Holloman looks at the planet's enduring appeal.
The first historical references to Mars come from Mesopotamian astronomers in what is now Iraq. They found it in the sky 3,500 years ago. What set it apart from the other heavenly objects then still sets it apart: the color. Even without telescopes, Mars is the red planet. The Romans named it for the god of war. The Babylonians called it Nergal, the god of death and pestilence. When Nergal is dim, it is lucky. When bright, unlucky. Those words were recorded on a cuneiform tablet more than 3,000 years ago. Earthlings have always wanted to visit Mars. It's the closest planet to our own, and as knowledge of the red planet has increased, so has the realization that Mars and Earth are not that different. A day on Mars is just 37 minutes, 22 seconds longer than a day on Earth. Mars is tilted on its axis, just the way Earth is, which means there are 4 distinct seasons there, but because it takes twice as long to go around the sun, the seasons are twice as long. Its size, just about half that of Earth. Before the first telescopes, it was assumed that Mars was inhabited, and early telescope views confirmed that notion when it was noticed the planet was crisscrossed by what appeared to be canals. They must have been built by Martians. Percival Lowell used a 24-inch refracting telescope to look at the red planet. In 1895, he wrote, "The canals were the work of intelligent beings." He described Mars as older than Earth, with dried-up oceans, continents all smoothed down. He was convinced the canals were an elaborate irrigation system, and everybody believed him. Even after better telescopes showed the planet's barren surface and probes from Earth traveled the surface without finding any sign of life, the allure of Mars continues to draw us to its surface. The recent discovery in Antarctica of fossils which might have come from Mars and which seem to contain microscopic live creatures raises the intriguing question: was Percival Lowell right? And makes the race to the Martian surface even more exciting. John Holloman, CNN Atlanta.
Just minutes from now, a Russian Progress spacecraft is scheduled to be launched from the Baikonur Cosmodrome. Its mission is to take repair equipment to the crippled space station Mir. Meantime, a ground crew is working underwater to simulate the needed repairs. Russia's most famous cosmonaut, Sergei Krikalev, is to be the chief advisor when the work begins around July 17th, and he's leading the underwater training exercises at Russia's Star City. Mir was crippled on June the 25th in a serious collision with a cargo ship. An unmanned Russian spacecraft as it lifted off a short time ago from the Baikonur Cosmodrome. It's carrying repair equipment to the crew on the crippled space station Mir. The Progress cargo ship is to dock with Mir on Monday. Mir was damaged on June 25th in a serious collision with another cargo ship. The first Pathfinder pictures from Mars have been exciting for many people, but a group of people who met in California on Friday get almost starry-eyed when it comes to planets. CNN's Ann McDermott has more.
Space. What is it about space that prompts hundreds of people to spend the 4th of July inside, checking out such things as knives made from meteors, their images in infrared, and paintings, lots of paintings that don't prove there's life on Mars, but may prove there's at least still life there? Well, these are members of the Planetary Society, a serious-minded group dedicated to exploration of the solar system. No, they're not all rocket scientists, but we did find a few, like this fellow who thinks we will travel to Mars one day.
Like the retirement homes for us, you know?
That's where our children want to put us, far enough away.
Well, he laughs now, but he and the others clapped when the Mars probe landed. And there was lots of excitement when the first pictures were shown here at Planet Fest 97. And former astronaut Buzz Aldrin was not surprised.
It's history in the making as we begin to peel back the coverings on knowledge about what our surroundings are like.
Kids were excited too, but don't talk to them about aliens.
Do you think there are other people living on other planets? No.
But they don't mind. They just like space.
It's cool.
Even cooler is that this Independence Day, we turn the tables. This Independence Day, Earth invaded Mars. Ann McDermott, CNN, Pasadena, California.
A Progress spacecraft was launched a bit over an hour ago from the Baikonur Cosmodrome. The launch was monitored by Russian Mission Control. The unmanned craft is taking repair equipment to the crippled space station Mir and is scheduled to dock with Mir on Monday. Meanwhile, a ground crew is working underwater to simulate the needed repairs. Russia's most famous cosmonaut, Sergei Krikalev, is to be chief. We join a news conference being held by the U.S. space agency NASA on the Mars Pathfinder mission. We're taking you live now to Pasadena, California, and the Jet Propulsion Laboratory for that. Let's listen in.
The path that the ramp would go through. So that's why we decided to try to get those airbags pulled a little more under the pedal. So can I have the next picture, please? Okay, you can see, here's an after picture, that it's considerably improved. It looks like you can see the edge of the pedal here, and you can see that it looks like the airbags are comfortably below that edge. So the rover people took a look at that. The only problem is that we can't quite see the full extent of, we kind of had the picture chopped off here. So we're still not fully comfortable until we get a few more pictures back down to deploy that ramp. But it looks a lot better than it did before. Some of the other activities that we went through are to deploy our atmospheric structures instrument and meteorology science mast. So we sent the commands to do that, and Dr. Tim Schofield will tell you a little more about that later on. Let's see here. We also made the decision, based on images, to deploy the front ramp because it looked like there were no obstructions in front of that. The sequence that we sent up actually does a couple of things. It deploys the front ramp. It'll also release, fire the pyros to release the rover, and then the rover will actually stand up. However, due to the activities that we had to do before then, this was pushed very late in the Martian day, and we did not get confirmation, which we were kind of expecting because we sent the sequence so late. We did not get confirmation of those activities because the Earth had already set. So tomorrow morning we'll get our first confirmation that those activities were successful. We are working a couple of issues. The things that we had planned to do, or hoped to do rather, today that we did not get done was, first off, we wanted to get the IMP deployed. Now that means the IMP is on an astromast, and what we wanted to do was fire the pyro to release that mast and pop it up to its full extended height. The reason that we did not deploy it today was due to the airbag retraction activity and some of the other activities. We did not get a chance to take our what we call our insurance images, which basically is a set of images taken by the camera from its stowed height, so that if something were to go wrong during the deployment process, we would at least have a full pan of the surrounding area. So we wanted to make sure that we take those insurance images before we deploy the camera. So our plan now is to do that tomorrow, sometime tomorrow afternoon. The other activity, of course, is we did not get a chance to drive off the rover. The major issue that we are still working right now is we have an issue with rover to lander communications. The first health check, or the first couple health checks, we did get good data from the rover, but we have not been able to get communications from the rover since then, and Jake will hopefully be able to add a little more to that. That's it for the lander.
Okay. I wanted to review a little bit some of the things we've learned about this remarkable place that we have just discovered. give you some idea of what the thinking of the scientists on the team is, and some idea of the overall excitement among our science team, almost 100 strong, about this place that we've just landed at. Shown in this first image, this was released at the last press conference, we see a terrain that obviously has a series of dark rocks in it with light, sort of reddish dust that you can see here. In some situations like this over here, it almost looks like these rocks are imbricated one on top of another as if they were deposited in a high flood regime. And that's the early thinking that some of these rocks may be flood deposited, which of course is not at all surprising since this is the biggest flood in the solar system. Next one. That's a closer up look, and you can see these rocks look like they're sort of tilted on end with a structure within the rocks as well. So some very interesting things to look at. Again, a reddish dust. There's different colors rocks. They're dark, but there is some indication in some of these areas that there may be some slightly different color rocks, as shown by red-blue ratios in these images. Next one. Again, off to the horizon, this site has substantially more relief than anywhere we have ever seen on Mars. We believe these are, hundreds of meters that we're looking at here. And as I showed you earlier today, both of the Viking sites that we've been on have been remarkably flat. And so we actually believe we have an idea of where we've come to rest on the surface of Mars by looking at these hills in the distance and using the directions that those hills are, and I'll give you some idea of that. Next one. Finally, we do see a variety of different, not just rocks, as I said before, but finds as well. It looks like there's a variety of different finds in this site. There's this so-called cloddy material, which is kind of hard to make out in this, but it looks like it's a little bit more indurated than some of the real dusty drift material here, and there's some indications of almost sort of a white dusty drift material. So we have a much wider variety of materials at the landing site than we've seen at either of the other two Viking sites. And again, that bodes very well for our continued investigation of this site. Next one. So where do we think we wound up? Well, I would argue from what you're seeing on the horizon, we see large hills on the horizon. There's substantial relief at this site that we are not, and I repeat, we are not within any of these secondary craters. If we were inside a crater, we would see a nice bowl around us and we just wouldn't see anything out in the horizon. Certainly not things that look like they're that far away. So we have actually think that we are up out of this ellipse, which is the nav team's ellipse, somewhere off in this region here to the northwest of this crater, which we believe we have identified in the images. And this is a preliminary one. I won't go into detail, but perhaps tomorrow morning we'll have a more detailed description of why we think we are out on this plane out over here. I think that's it for the images. Just one other item. We have finally gotten an opacity measurement. That is how much material or dust lies in the sky. And as you all recall, there was some disagreement among the Hubble observationalists that were saying that we might see a deep blue sky and a very bright white clouds. It's clear we do not see that at all. In fact, what we see is an opacity of about 0.5, which is rather dusty. And probably, I guess Mars has the last word, as it always does. I was wrong on my prediction that it would be clearer than the Azusa Fire Day here in Los Angeles. It's about the same as that, okay? So we do have a dusty sky. It looks very much like Viking did. It's a salmon-colored sky, and that opacity is a bit higher than what we had expected, and that will reduce our solar power just a tad. And with that, I'd like to turn over to Jake Matijevic to talk about the rover.
Okay. If we can go back briefly to, I guess, the prior image might be helpful, showing the, back one to the, showing the, one of the early images of the rover and the, on the pedal. Yeah, that one. As Guy pointed out to you that in the confirming image that we took a little later, this section of airbag material has been brought down behind the rover's pedal. It now clears up an area in front of the this pedal, and gives us now another attempt at calculating the actual position where the front rover ramp would deploy. That ramp will deploy in this area at about an angle of 24 degrees, maybe a little shallower than that. So this is actually a very safe, would be a very safe deployment for the rover off the front of the rover's pedal. I think what Guy mentioned, there was still some obscuration in the rear. We also took some additional rear images after this pedal motion and airbag retraction took place, and we had some obscuration in that area of precisely the area where we were looking to get some confirmation, where the airbag material was laying over one of the rear ramps, a portion of the rear ramp. At least from the images that we did see, it looks as though that material has also been retracted, but we didn't get a full view of the ramp as yet. So we went ahead with the commands to actually deploy the front ramp, and as mentioned at the beginning here, that command went up. The confirming images have been were queued to be taken, but the data will not be returned until tomorrow morning during our first downlink. The second issue that Guy raised had to do with the problems we've had with communications between the rover and the lander. The way that's manifested itself has been in the form of a high percentage of garbled frames and transfer between the two modems. For those of you who are not familiar with the communication system, it's actually a radio modem system, one on the rover, one on the lander. The rover, as link commander, routinely and regularly interrogates the lander for commands, and the lander's modem is on from the early morning period till late at night, and actually acting in sequence with the rover, attempts to communicate, attempts to receive these packets of information that the rover is sending, and stores them and buffers them for transmission to Earth. The manifestation of the problem we've seen has been of the form where the rover has continued to try to send telemetry to the lander. Some of it gets through. They're more along the lines of communication sessions that set time, begin the acknowledgments associated with commands and telemetry sessions, but quickly abort about the time when the larger frames of data containing information about the rover's health, other status information as we go through the command sequences on the rover, the confirmation of the execution of those command sequences being reported by the rover to the lander. We tried one attempt to power recycle the lander's modem. That didn't seem to clear the problem at this last communication session. We're going to try several recycles or power recycles during the night. And of course, because the rover is power limited, it routinely and regularly power cycles its modem. So we're going to see if that sequence of activities over the course of the next several hours doesn't clear the problem by tomorrow morning. As Guy also said, we did queue the sequences that would stand the rover up. In all likelihood, the rover did not receive those sequences. This communication problem is severe enough so that sequence probably was not received by the rover. But again, we will not get confirmation of that until tomorrow morning's telemetry session. There's no danger at this point either for the rover. The release pyro events that we just did command that include releasing the forward ramp, releasing the rover, and releasing the tie down of the APXS sensor head can proceed without these other portions of the command sequences on the rover being executed. The rover is tied down even after these tie down cables are released. The rover actually has 6 wheels caged prior to stand up, so it's not going anywhere at any time over the next several hours. and we have full opportunity tomorrow to, once we've gotten the confirming data, to repeat this process of attempting to stand the rover up. But in all likelihood, what's happened today is when we get these confirming images, we'll see a front rover, a front ramp deployed, still a stowed rover on the lander's pedal, and an opportunity to try to drive the rover off the pedal tomorrow. So with that, I'll turn this over to Tim Schofield to talk about the ASI MEP situation.
Whilst all these great images were coming down this afternoon, we were having our own excitement on the ASI MEP, verging on nervous breakdown. We planned to deploy the mast after the first high-gain downlink, after we'd expected the pictures that were displayed. We found to our dismay that we couldn't see the mast in the pictures that came down due to a slight difference between the testbed hardware and the actual flight hardware. An object near the camera was obscuring the view of the mast, so we had no means of telling whether the airbags were blocking the mast deployment or not. We have very delicate thin wire sensors on these masts, and even brushing against the airbags would tear these sensors. We delayed any action until the second downlink, after the rover petal manipulations, and there the pictures were just a little better and allowed us to see the bottom corner of the mast, and that would look clear, and other indirect information persuaded us that the mast itself was clear of the airbag, which probably wasn't overlapping the petal, and this indication was also strongly reinforced by the mission manager, who reminded us that he was losing 20 or 30% of his solar power from the panel whilst the MET mast was down. So we decided to deploy the MET mast on what information we had, and in the final downlink, the last packet received in the final downlink showed the MET mast had deployed. Some images showed the mast vertical, and we had one data session in the fully deployed position. All of our sensors are working correctly. And the first figure shows the Viking temperatures with a few of our sessions average superimposed on that data. Only the last point, this point here, is with the MET mast deployed. Before this time, all the temperatures are very much higher than Viking, almost at freezing point here, 32 Fahrenheit. When the mast deploys, we're looking higher in the atmosphere, a meter above the surface rather than a few inches. The temperature drops down much closer to the Viking level. Should remind you that Viking was making measurements at 1.6 meters, so we would expect to be a little warmer than Viking during the day, because we're still close to the surface. So this, for example, this is 1.6 meters, this is 1 meter, and this is a few inches above the surface, and it sort of gives you an indication of how the temperature is varying with distance from the surface. As we'll get no more data today, tomorrow afternoon we should expect to see an entire daily cycle in our data set and get a good comparison of the daily cycle on Mars. The next image shows same data for pressure. Pressure is not influenced by the mast deployment. That's taking measurements out in a completely different location on the spacecraft. And we were astounded by the agreement between the measurements we'd taken and the old Viking data. We have much more resolution, but we seem to follow pretty much down this Viking curve for this time of the day. The last point is about 1:45 in the afternoon. We have preliminary wind measurements for this last point in the mid-afternoon. The wind is blowing from the east-southeast. It's very light, a few meters a second at the most at that particular time. Tomorrow we should be able to produce time variations overnight and during the most of tomorrow of the variation of wind. So after a bit of nail biting on ASI MET, we're all now feeling very pleased that we're seeing good quality data coming back. Thank you.
Just one more thing before questions. To give you some idea what we're expecting tomorrow, we obviously will try to get the rover off by the imaging tests we've already talked about. We also will almost certainly not deploy the IMP on its mast this evening and wait until tomorrow to take a series of panoramas additional to the ones you saw on NASA TV coming down this evening. We now have a panorama in that one color, but we would like to get panoramas in other colors as well prior to deploying. So we will maintain the imager in its state. We will continue to take weather data, and we will try to get the rover off.
Okay, we've all had a very full day, and many team members have to do yet more work, so we'll try to keep the Q&A session fairly brief. Let's start over here with Casey.
Hi, I'm sorry, I don't quite understand how you're going to be trying to communicate with the rover, recycle, do things this evening. Hasn't the Earth set? And could you give us a little time schedule for tomorrow when things might happen, Earth time, and what time, when that is on Mars?
Sure.
Thanks.
I'm sorry, I didn't mean to be obscure here. The rover is actually running the first sequence that it received this morning. That sequence contains commands that actually are executed overnight and tomorrow morning. During the course of the execution of those commands, it routinely and regularly attempts to communicate to the lander. Now, those commands are synced up with other commands on the lander, which bring the LMRE, the lander's modem, online for communication with the rover. So the sequence of activities is such that the rover is, over the next several hours, will be continuing to attempt to communicate with the lander. Overnight, the rover will shut down and wake up hourly, continue to attempt to communicate with the lander, and this will go on through really through the rest of the morning as well. The command sequence that's on the rover right now actually runs into day 3, runs rather benignly in that regard, periodically just communicating health check information, health status information concerning the rover. The sequence of events that will take place tomorrow start roughly with the first downlink that is coordinated with about 8 or 9 o'clock. I believe it's actually 8 o'clock a.m. local time on Mars, which is roughly about 4 o'clock 4 o'clock in the afternoon Pacific Daylight Time. And then we proceed from there through what is something like what took place today. There'll be opportunities during the course of the remaining evening and into the into the night, where we'll have opportunities to be able to command sequences to the lander to be sent to the rover. We'll have perhaps some other activities to perform both on the lander and possibly also on the rover to try to clear this problem. And that's those sequences and those activities what we'll be talking about building tonight and tomorrow morning.
Okay, Todd?
Todd Halverson of Florida Today for Jake. I'm wondering if you could give us an idea of when you think the earliest the rover could roll off. And for Mr. Schofield, I'm wondering if you could tell me again what the temperature was in Fahrenheit and what the wind speed was that you saw in your data.
Okay. I believe the earliest we'll be able to roll off tomorrow will be something on the order of about 7:30 tomorrow night. That's local, that's Pacific Daylight Time.
Okay. I'm sorry. There was a part
on the temperatures, after the mass deployed at about in the heat of the afternoon at about 1:45. We showed on our top mass sensor about 1 meter upper temperature of about 255 Kelvin, which corresponds roughly to about 0 Fahrenheit.
Okay, want to get the microphone to Bill Harwood?
Just scaring me.
Bill Harwood, CBS. Is there any idea what the possible cause is for the garbling between the modems? Have you seen a signature like that on the ground in any testing? I mean, or is this a complete unknown at this point?
We haven't seen it for some time. There is some indication. We've been polling our engineers, and they've been kind of going back through their activities, their notes and such, that we've seen a variation of this, where the two modems clocks are out of sync for one reason or another. We think the power cycling is a means of clearing that. There may be other ways of attempting to clear the problem, which we think is on the lander side of the interface. But I wouldn't like to speculate here at this point. I don't think we've had a really adequate time to fully diagnose this problem and give you a most likely reason as to why it's occurred.
And a quick follow-up, and this may be a dumb question. I was under the impression from what you said that you see this with big chunks of data going through as opposed to smaller packets.
No,
is that
actually,
right?
no, actually, we've seen small chunks of data going through. The large chunks of data are not getting through, and that's consistent with a communication rate that's degraded quite a bit.
And that's where I was going with that. Is there, if you never could resolve something like that, can you send commands in smaller chunks and get around that problem down the road at some point?
It's possible to do that. Again, I would prefer not to speculate at this point.
Jim Vocek, CNN. When the rover drives down tomorrow night, do you have a plan at this point where it's going to go exactly?
In all likelihood, it's going to go down the front ramp. This is what we'll attempt to do tomorrow is consistent with what we were trying to do on the best of circumstances tonight, which is to really do a very short traverse at the end of the ramp, do a turn, roughly anywhere from 45 to 90 degree turn right into an area that's clear at the end of the ramp, and put the APX down to take our first night or first soil measurement overnight on Salt 2. That would be the nominal plan to be performed tomorrow.
Okay.
Eric Simon, Mosaic.com. I have two questions. Number one, if the option always existed to deploy the ramp out of the rear, why was that option not pursued? And question number two, if the modem issues, the communication problems are not resolved, how will that impair the rover's mission?
The problem with the rear ramp deployment is that we didn't get a confirming image on this downlink that showed that the airbag material that was draped over the one edge of the ramp had been removed as a consequence of the airbag retraction and pedal move activity that was conducted tonight. That was the reason why we didn't deploy the rear ramp. Otherwise, the images that we did get of the rear area of the pedal indicates that the airbag material did move, that there does not appear to be any obstruction otherwise of the ramp deployment. We just did not want to risk deploying that rear ramp, given the absence of this confirming image information. Again, I'd like not to speculate as to what would happen if we do not reestablish communications. There are some contingency options that could be exercised in that instance, which will eventually drive the rover down the front ramp and onto the surface.
Leo?
Leo Enright, BBC. Can I really understand precisely this modem thing? If the modem isn't fixed, the rover's going nowhere. Is that basically it?
If the modems were not fixed, okay, the contingency options include the execution of commands that are already stored on the rover to do what I've just mentioned, deployment down the front ramp and deployment onto the surface of Mars. We would prefer to command that activity from the lander, and of course, any activities that would follow this would require communication between the rover and the lander to get to sites on the surface, etc., to do the kind of mission we're talking about. We have every confidence we'll find a way of being able to resolve and fix this problem so that the mission can proceed normally from this point on.
Can I just follow up and ask, what is the scale of the troubleshooting that's going on? Have the contractors been called in? Are we talking about teams who are working tonight, through the night?
We were trying to organize that when I left. I'm sorry, I don't have more information for you at this point.
Okay, let's just take a couple more questions and see if we can wrap up. Seth, the front row.
Seth Bornstein, Orlando Sentinel. Just to follow that a little bit more, I guess I'm tired and having trouble. So you're saying if the modem problem isn't cleared, you can still get down on the ramp, but then after that you really can't do anything. Is that, you can't, if Matt wants you to go to Rock X, you really can't go there, right?
That's correct. We won't be able to do a commanded mission if we don't fix the communication problem. But again, I'd like to think in terms of being able to resolve this problem, in the next day or so.
And Matt, once, let's say everything goes well, and you go down and do that, get up and do the little just right turn and take a look at the soil. After that, you see this whole field of rocks from this panoramic view. Besides that first one where you just look at whether it's nearby, is there already a priority which rock whatever you want, and what is it?
Yeah, there's, in fact, the Mineralogy and Geochemistry Science Operations Group, that's what our working science groups are called, SOGs, has already prioritized rocks off the front and rear ramp. There is a sort of...
It's a reddish rock.
No, it's a dark, it's a deep blue, a deep dark rock that would be in the direction that he turns, and the whole point of going down and turning right is in fact to get to that one. I could probably show you which one that is if we try to cycle through the images if you're really interested.
And what makes it so interesting?
Oh, it's a dark rock that doesn't have, there it is.
Go to the previous one.
Yeah, go back one, please. That's it, right?
That's it there, yeah.
This is a rock that does not look like it's covered with dust. It looks like it's a deep blue native color, or deep gray, if you will, and thus implying that you're looking at the rock mineralogy and not dust there. So that would be the target for Sol 3, provided we go off the front ramp. If we go off the rear ramp, we also have a rock that meets the same sort of criteria. It's dark and deep in color, and it does not appear to be dust covered. Well, we don't have the stereo out there yet, but you know, it certainly looks within range. It's certainly smaller than a meter.
Okay, we have two questions from Kennedy Space Center. We'll take them now.
This is Phil Chen of Earth News. I guess starting from when the crew stage separated through your command to fire the pyro to let out the ramp, how many different pyrotechnic devices were set off either over or on the surface of Mars? How many fireworks did you have on Mars today?
Well, the number was in excess of 40.
Yeah, I think
I don't have an exact number.
42 just to get down to the surface, and then there's additional ones to unlatch the imp and the high gain and so on. So we're probably of the order of 50 or so.
Okay, and a much bigger number. Do you have any estimate on the number of internet hits you've had to your webpage and all of your mirror pages around the world today?
Yes, very close to 100 million.
Okay, do we have another question from Kennedy? That's it. Okay, I guess we'll call it an evening. Thanks for joining us. Our first press event tomorrow is a 10 a.m. briefing in the auditorium.
Okay, well, you were watching a live press conference held there by NASA scientists discussing the Mars Pathfinder mission. They were trying to be very positive and upbeat, but apart from a partially deflated airbag blocking the Sojourner's path from the spacecraft, there is also a communications problem sending commands to the rover, which might hamper the whole mission. NASA are playing down that worst-case scenario, saying a lot can be done on Saturday daytime, U.S. time. They may well deploy the rover from the rear, but unless the communications problem is resolved, they won't be able to communicate with the rover. But as I say, they are trying their best to sound very positive, saying that everything is going according to schedule. They were showing off some rather fancy photographs from the surface of Mars, imparting a lot of the scientific knowledge which they've already gained at this stage. They also said a staggering figure that somewhere in the region of, was it a million or more internet site hits they've had just in one day since their mission began. That's the world news for now. We'll have a full report at the top of the hour, but World Sport officials are hoping to deploy the Sojourner rover on Saturday for its week-long exploration of the Martian surface. It appears that the front ramp of the Pathfinder space probe has been sufficiently cleared so that the rover can be deployed. Now, scientists are working to fix a communications problem between the rover and the landing craft.
U.S. Space Agency scientists on Earth are trying to work out a communications problem on Mars. The Sojourner exploratory rover is having trouble sending information to the Pathfinder landing craft. But NASA officials are optimistic the problem can be fixed, and they're hoping another problem already is behind them. CNN's John Zarella has more on that.
Mars, what it looks like 21 years after the last spacecraft successfully landed and sent back pictures. It has been a long time between snapshots. The color images show a wealth of rocks and boulders, hills, perhaps mountains off in the distance. A geologist's field of dreams. As the images came in, cheers of joy rose from the Pathfinder control room, one of the many moments of exhilaration for the space agency.
What better present can this agency give the nation on its birthday than this landing on Mars? It's just terrific.
So much had gone so well. All the engineers and scientists had expected glitches. But from the moment the vehicle began its descent to the Martian surface, milestones came and went more smoothly than anyone expected.
To imagine we would see the signal right after we landed, to know that the spacecraft was healthy after all of that, and then, of course, to have it come up right on target with the low gain, and then even more spectacularly, to come up right on target with the high gain, pointing within a degree of the Earth. Unbelievable.
There was no lack of emotion at NASA's Jet Propulsion Laboratory. Even the vice president called to congratulate the space agency team.
And congratulations on doing an absolutely outstanding job.
But perfection would have been too much to expect. The first black and white images showed the airbags, which allowed the vehicle to land so safely, had not retracted completely under the pedal on which the Sojourner rover sat. After testing a plan in a place called the Sandbox, engineers sent commands to the vehicle for the pedal to raise up and the airbags to be pulled in further and the rover ramp to unfold. But the flight team won't know for several hours whether the final command was carried out.
Looks like we will not receive that data in the last transmit session, but I would like to congratulate all of you on a job very well done.
It will likely be late in the day on Saturday before the engineers can get the Sojourner rover off of the Pathfinder lander. The engineering team has managed to save some of the drama for the second day on Mars. John Zarella, CNN at the Jet Propulsion Laboratory in Pasadena, California.
A cargo spacecraft carrying supplies for the stricken Russian space station Mir lifted off from the Baikonur space complex in Kazakhstan on Saturday. CNN Moscow Bureau Chief Jill Doherty joins us now with an update. Jill.
Well, Veronica, help is on the way to the Mir crew. Supplies, as you mentioned, to carry out these delicate maneuvers on Monday, repairing the Spectre module. Mission Control this morning from Moscow says so far so good, but big challenges lie ahead. The Progress M35 cargo ship blasted off from Baikonur Space Complex in Kazakhstan. 10 minutes later, it was in orbit around the Earth, scheduled to dock with the Mir space station Monday. At Mission Control outside Moscow, cheers and applause as scientists and officials monitored the launch on a large screen.
On the whole, the complex has been working very well since we corrected the problems with the movement orientation system. The climatic conditions, the humidity conditions, the electricity. That's all up to norm, and the complex has been prepared for the docking process with the Progress ship.
The cargo ship is loaded with more than 2 tons of repair supplies. The most important piece, a new custom-made hatch the Mir crew will install on the damaged Spectre module. Also aboard, half a ton of fuel for Mir, more food and water for the crew, personal supplies and underwear, as well as more scientific equipment for a French astronaut who's scheduled to join Mir this August. The Mir crew was given an additional 6 or 7 days to practice for the repair job they'll carry out on the damaged Spectre module mid-July. The Russian commander, dressed in a spacesuit, will have to enter the depressurized module and reconnect several cables from the solar panels back through the new hatch to the Mir's power system. Russian scientists say it's complex, but can be done.
It's not an easy task, and always it's some part of a danger in connection with every spacewalk. But they performed it, or cosmonaut performed it many times.
Now, Monday's docking actually is a similar procedure to what caused the Mir collision in the first place, but this time the Mir crew will be performing it automatically instead of manually, and scientists here say they're keeping their fingers crossed. Veronica?
Jill, how is the actual crew on the space station coping with all of this?
Well, the Mission Control this morning was asked that, and they said that they've been very, very tired. Actually, for the last couple of days, they really haven't slept because they've been having to maneuver the gyroscopes manually instead of automatically. So they're hoping that now that the supply ship is on its way, things can quiet down a little bit, and at least tomorrow, Sunday, they will be able to get some rest. Monday, they're describing as a very tense and intense day, so there's a lot of stuff to be done on Monday when that docking of the supply ship takes place. Also, the Russian Mission Control did say today that the 17th of July still is the tentative date for that spacewalk. Veronica?
All right, thank you very much. CNN's Jill Doherty there with the very latest on that repair mission to the space station Mir.
NASA officials are expected to hold a news conference on the latest details of the Mars Pathfinder mission. We're going to bring that to you live when it happens. Well, pictures of the dramatic Martian landscape have been beamed back to Earth as part of the U.S. Pathfinder mission. Scientists of the American Space Agency, NASA, say they are pleased with the transmissions that they have received, but there's a glitch that now casts in doubt how much detailed information they'll be able to record. For more on the story, we're going to go now live to Pasadena, California, and a press conference with scientists at the Jet Propulsion Laboratory.
On the planet seem to be watching and enjoying the moment with us as we went through the incredible events of yesterday, and of course capped off with the wonderful pictures that we saw. Well, we've got a busy day today, and we're going to give you a preview of what's ahead. At 10:08 this morning, Pacific Daylight Time, Earth will rise over the landing site on Mars. At about 1:19 this afternoon, the sun will rise over our landing site in Aris Vallis. What the team is up to this morning is that we've prepared, over the night actually, we've prepared sequences for a number of activities today. I think you heard last night that we don't believe we've deployed the rover ramps or had the rover stand up. We don't know that yet. We'll be taking some actions this morning to determine that. The reason for that is when we were commanding yesterday, the Earth was very low on the horizon. The antenna was basically looking low on the horizon and looking through other parts of the spacecraft, basically through the camera. And we do not necessarily expect those signals to have gotten in. We also had a downlink session last night around 9:30 in which we did not receive any data. And again, that was reported last night. And again, it was not unexpected because of the very low position of the Earth and the blockage of the antenna by the spacecraft. So at 1 o'clock this afternoon, we will be commanding the spacecraft. We need to talk to it this morning, let it know that we're here, waiting for it to wake up, and or we will basically wake up the spacecraft, that we're ready for today's activities. We have a couple of things we're going to command the rover to do at the same time. And we'll just get a very brief signal back from the lander that it received those commands. So this is just, we'll send up some commands and it'll signal back, it'll turn on its transmitter for just a couple of minutes to say, I heard you, I understand you, we're going to go off, I'm going to go off and execute those commands. But we won't know, in fact, that it's done all those things until 3:20 this afternoon when we receive our first regular communication cycle. We'll be getting telemetry down from the spacecraft. It will give us the spacecraft health, tell us how it did last night, did it sleep well, have any nice dreams. I'm sure it's having a wonderful time sleeping, as some of us got a little sleep last night. If everything looks good in that telemetry, well, I'm sure it will look good. At 5:58, we will have sent a command to execute the ramp deploy and the rover stand up again. Since we don't know whether it's happened, we would know if it had happened at the 3:20 downlink. Assuming it did not happen, we will send that command again. And that's to deploy the forward ramp and have the rover stand up. And again, the spacecraft will respond with a short semaphore saying, we understand the command and I'm going off and executing it. The real excitement then starts a little later at 6:28 when we should get back our images of the rover ramps deployed. Rover ramp, just one ramp right now, deployed onto the surface of Mars. And some additional images will also come down at that time at 6:28. Depending on what we see there, if it looks safe to deploy the rover, if the ramps are in a good orientation, that there's a good place for the rover to drive off to. We'll make the decision to deploy the rover as early as about 7:40 this evening. And then about 9:58 or 10 o'clock, we should receive back images of the rover on the surface of Mars. Now, again, all that's contingent on an issue we have with rover communications. Right now, Jake will go into this in a lot more detail, but let me just say that we have a condition in which communication between the rover and the lander is degraded. We're hearing each other, but we're just kind of getting one syllable, across the net. We're not getting full sentences. We're really not able to communicate. So we're kind of in a degraded mode. The rover team worked very hard last night to look at various options. What can we do? There's a lot of things that we can do to fix these things. It's amazing what you can do from 120 million miles away, as of course the Galileo team demonstrated so incredibly with the unfortunate high gain deployment problem there. But obviously, I'm confident, I think our team's very confident, we'll get to the bottom of this problem and we'll get the rover off hopefully sometime later today. Thank you. My esteemed colleague, Dr. Peterson.
Yesterday, I described the experience of flying economy class to Mars and showed the first views of the Martian landscape. Today, I'm able to extend that view and to show the original view in a little different fashion. Every day now, with the help of the IMP science team, the project engineers, and the image processing lab, we will be revealing more and more sophisticated views and interpretations of the neighboring planet and the wonderful place in which we've landed on that planet. So if I can have the first view graph, or the first slide, I want to show you where we think we are on Mars. Now this is, oh, I don't have this monitor on.
There you go.
Okay, we think we're up here. And notice how close we came to a rather large crater. Very close. Like having a little trouble seeing the monitor, but...
Looks like they cycled.
Well, that's actually one of the reporters just tried to turn it on. Skip, this monitor's not working.
But where these lines come together is where we think we are. And the lines are showing objects that are significantly above the local terrain so that we hope to see these objects on the horizon or nearby. So the first thing we've all noticed yesterday in the pictures is a little bit of a hill right behind the rover, and that's this little knob over here to the left. And in the distance in that frame, although it was probably hard to see and maybe impossible to see, but we have seen it up in the science area, we can actually see this large feature way in the distance. Now this is 20 miles away. And of course, since the atmosphere opacity is more than we thought, we can actually see the haze influence between us and this distant mountain. So over the next few days, we'll be showing some close-ups of what it looks like to see a distant peak of this sort. But first, let's show the pictures yesterday in a little different fashion. And if I can have the video. The first video shows the scene that was presented yesterday. And now we are scanning from left to right. And this is now a more sophisticated way, of course, to look at the images. And we can see that hill in the background, which is actually sort of a Twin Peaks there, little saddle. And now we see a geometrically rectified scene where the rover doesn't have the banana shape that it did in the pictures yesterday. Now, everything is straight lines there, and this is a more correct representation of what we're actually seeing in the landscape. Okay, let's go to the first still, and that's the same picture. The next picture, please. Well, the next picture is that one that's the, there it is. The rover now geometrically rectified so it doesn't look distorted as it did yesterday. And there's a few things I'd like to point out to try and encourage your thinking about what this landscape might be, just as we're encouraging our own thinking. One is this interesting group of rocks here. If you may have noticed, or you may not have, that they all seem to be slanted, kind of in a northwesterly direction. this rock here, this rock here, this one, and this one. They're all kind of leaning towards the northwest. Now, if you remember from the introductory remarks in the last few days, we're in a floodplain channel, and the floodplain is flowing from south to north. Could these rocks be oriented that direction because of the influence of that last flood? This is a question that is being asked up in the science area. Now, of course, I don't know the answer, but just to help you think about the picture. We also see, if you look closely, that the soil is not all the same color, that there's areas that are more brightly colored and areas that are darkly colored. So there's definitely two different types of soil here. That may be that some of the soil is brought in by a wind process and dropped onto this scene and therefore isn't really native to this area, or it may be for some other reason. But in any case, we also see a few different areas that seem to be a little bit redder, and they're somewhere in this area here. These are areas we hope to send the rover over the next week or so. And we're also looking at a couple of rocks as places for the rover to visit once she gets off her pedal. And one is this rock here, and we're going to take some close-up views, I believe, tomorrow of this rock with all of our filters and try and make a scientific assessment. And the other rock we find interesting is this sort of tabletop rock over in this direction. So these are the things we're thinking about in this picture. We know now that this hill is not a crater, that it's just a small knob that would show up in the Viking picture as a little bump. That's not, even though it looks kind of like a crater rim, it's not a crater. Now let's take a look at a new view. Turning to the south, unfortunately we have no color imagery yet. This is the red filter. It's compressed 12 to 1. This is what looks to me like a Viking scene. It's kind of flat, lots of rocks, but small rocks. This close one is not all that high, really, because we're down so low, it makes it look a little high. Now, these breaks in some of the lines here are caused by parallax. That target is just right close to the camera, and as we turn our head, as you would turn your head looking at your finger or some other close-by object, it moves against the background. So it's very hard for us to line up the close-by objects. And down here, you can see where the azimuth mast is. This is taken early yesterday, and therefore before they deployed. But now let's look at, this is, by the way, if I didn't mention, towards the south, and this is the rim of that big crater that I showed in the first picture. Several kilometers across, that's just the edge of it. And if you look very closely in this picture, there's a little bump on the horizon. We think that's way in the distance, one of those knobs that the line in the first slide was pointing to.
How far in the distance is that crater?
All 3-4 kilometers. And unfortunately, the low-gain antenna, which is this object right here, hides the rest of the crater. So even if we showed the rest of that picture, you wouldn't see anything. But as soon as we deploy, we'll look over that low-gain mast, and we'll be able to see a very nice view of this crater. So this is something to look forward to when we deploy our camera at the end of the day. Right, Brian?
Yeah. Whenever you decide you want to deploy it, Peter. Yeah, we would normally deploy it after we complete the set of images coming down around 6:30.
Okay, now we've looked to this is pretty much a view to the south. Let's turn around and look more towards the north in the next slide. Now the picture, those are the first picture I showed sort of ended right here, and now we have some additional information that I can show, and this big rock, which is, I'm just guessing because we don't have stereoscopic views yet, but I think it's at least 1 meter in height. It's probably as high as the camera is because you can see it's lined up on the horizon. We came very close to that rock. Now, if we're landing with thrusters and landed on a rock of that sort, we would be in real trouble. So the airbags, again, have worked really admirably. We again see the scrape marks where the airbags were retracted. Some of us think we can see additional scrape marks from when the airbags were re-retracted. Mm-hmm. And this is a rock we're quite interested in from its color properties. I don't have a slide to show that, but I will soon. But the most mysterious thing in this picture is this little object on the horizon that has been likened to a couch. Somebody suggested there was a homeless person camped out there. But I thought it might be the parachute. Brian thinks the parachute is brightly colored, and that couldn't be the parachute, and therefore the geologist, of course, immediately thought it was an interesting rock feature. But this is definitely something we're going to be looking at, and as we're allowed to change our sequences after deployment, we're going to look at that feature with all our color filters and try and see if it's different in color from the other rocks. So that's what I have to show today, and the rest of the day will be spent finishing the nominal SOL-1 sequences that we were not able to complete yesterday. And we have to finish those before we can deploy because we have what we call our insurance pan in there just in case something happens on deployment, which is actually a very violent activity. Our longerons that you can see in the model on the left are thin fiberglass rods built by Able Engineering, and they are coiled down into the base canister, held down by a pin. When we pull that pin, this thing springs up and actually has enough rotational force to coil itself back down again and come up several times. So it's quite a violent operation as we deploy the camera, and that's why we want to have an insurance pan, which is some 280 megabits of data taken around and around. And if something happens, we'll have a tremendous wealth of data to draw from over the next few weeks. It would take weeks to get all that back. So we want to be sure we have that stored in the memory before we deploy. And after we deploy, we're not so much interested in what's in that memory. We're going to take new pictures. So that's happening today. We're measuring the opacity of the atmosphere. We think the dust is thicker than was first thought. It's really quite dusty, and we're going to be studying that dust. Could it have something to do with the dust storm? Well, I really don't know, but it is particularly dusty. We're going to take a close-up view of the soils and down there where they're disturbed, and this will be our 12 filters, lossless. This is our best view of those soils. That'll happen today, and we're going to complete our 360-degree view, and I'll be able to show you that. The one section that remains will be shown at as soon as we get the data and can process it. So with that, I'll turn the microphone over to Jake to talk about the rover.
Hi. Yes, let me briefly recap the situation that took place yesterday. We had, as you know, we had performed our pedal motion, airbag retraction activities yesterday to give us a better chance of being able to correct a problem of airbag draped over the rover ramps. One of the things we'll try to do today is to send the commands up to deploy those, at least the front ramp, and get some additional imaging of the rear ramp area so that we may even be able to deploy the rear ramp sometime later today. That will be, that will also accompany that will be the actual release of the rover tie downs. There's 3 tie downs, one on each side of the vehicle, and a tie down of the APXS. And that will prepare the rover for stand-up and deployment to the surface. The communication problem, which is the one that we worked late yesterday and then overnight, manifested itself as a lack of communication between the complete communication between the rover and the lander. We have indications from some of the lander telemetry that indeed the rover has been mightily attempting to send information to the lander to send back down to Earth, and only the shortest frames of information in those communication sessions have apparently been getting through. We are in a position where we can actually request additional diagnostic data that was collected by the lander during the course of yesterday's activities to help us in attempting to isolate what this problem would manifest itself, how it manifests itself during the day. The other thing is that we did last night as part of the actual nominal execution of activities both on the lander and the rover were that the lander modem was power cycled several times during the night. The rover power cycled its communication system every hour overnight. It actually did a full shutdown every hour overnight. And we had some thoughts that this combination of power cycling would be one means of being able to correct what appears to be a something like a synchronization problem or other related cause for this absence of communication between the complete communication between the rover and the lander. Now that information will be the diagnostic information will be available, as well as any telemetry that actually did get through from the rover to the lander during the 3:30 to 4:30 downlink, 3:20 to 4:30 downlink this afternoon. Prior to that, we'll also try two other things to help us in diagnosing this particular problem. On the lander modem side, we actually have a redundant power converter that supplies power to the lander's modem. We'll attempt to use that and repeat some communication attempts prior to this actual downlink activity. And also, we are going to attempt to send a short command sequence to the rover this morning and see if that gets through. The short command sequence will basically just reset a couple of parameters, and if it gets through, it'll give us some additional information about what portions of the communication link between the rover and the lander are still functioning and functioning well. But through analysis of that of the results of those commands and the analysis of the diagnostic data that we will receive from the lander, we may have some better information and some better insight as to what to try next to ensure that we can reestablish solid communications between the rover and the lander. Again, in all likelihood, some of the things that are already taken place over the course of the last several hours may have already corrected this problem, but we will not know that until later today. And Brian already went through the sequence of events if all the rest of this activity goes well, in particular if we do reestablish communications, and that would include deploying the rover to the surface of Mars sometime later this evening. And that's a good place to stop.
I'd just like to add a couple more things. In response to the request of one of the reporters yesterday, we will up the data rate just to get down more images for you. We'll be effectively doubling the data rate to about 4740 bits per second, starting with our 320 downlink. In addition, we'll be doing some more science observations. We'll be imaging the magnets. We'll be looking into the atmosphere for dust, and we'll be looking at the windsocks, see what the wind conditions are. So keep that camera busy. So that's all we have.
Okay, we'll go to Q&A here. Let's get a microphone down here in front to Bruce Smith.
Bruce Smith, Aviation Week. The fact that you're just getting the shorter frames in, what does that tell you? I mean, what do you suspect? Or does that narrow down the problem somewhat?
Yes, what we've seen evidence of is that the shortest frames of information have been getting through from the rover to the lander, and that's indicative of a degraded communication link, not an absent communication link. And what we'd like to confirm is at least that of the things we saw yesterday in the telemetry from the lander, that these were primarily associated with activities of the rover's initiation. That is, the rover sending data to the lander or requesting data from the lander. Now, we'd like to check one other communication session that is part of our communication link, and that is the ability to be able to command the rover. We had not done that yesterday. If you recall, the sequences we tried to send up late last night probably did not reach the lander and were not executed. So we'd like to do this short sequence as another test to gather additional information about the nature of that link.
Todd?
Todd Halverson of Florida Today for Brian. I'm wondering if you will deploy the rover before the communications problem has been resolved. And if you do give a go-ahead for the deployment at 7:40 p.m., give me an idea of how long it takes to actually get on the ground.
Well, let me say that if we still have this communication problem, we probably can't, we don't know whether it's a one-way or a two-way communication problem. We don't know whether, in fact, we can command the rover. And we'll learn that later today. We don't really have any way to, if we can't command the rover, then obviously we can't deploy it, because it has to stand up on its own. We can release it, but then it has to drive its wheels together in order to stand up. And so that takes action on the lander's part and on the rover's part. So we need to get this.
Brian Muirhead, who's one of the project managers for the Mars Pathfinder, just giving reporters some bad news. If we can't command the rover, we can't get it to move. This could be a big problem. They don't know whether it's solved or not because of the difference between the light on Mars powering the solar panels and when the rover area on Mars is connected to planet Earth. We got some new pictures. They enhanced some of the pictures they took overnight, and now we know precisely where the Mars Pathfinder is located on the Martian surface. But the headline in all this from Brian Muirhead, the project science manager, is that the rover is at this point stuck there on the Pathfinder lander. It's got its own cameras, as Jim Hill showed us earlier today. And the big goal of this is to get that thing off the Pathfinder, out on the surface of Mars, going around to rocks, sniffing them, finding out what they're made of, and showing us some more of the fabulous pictures like those we have seen in the past 11 hours. We'll take a quick break. We'll come back and talk about more of this and show you the latest pictures with a little explanation. CNN's coverage of the Mars Pathfinder landing continues.
Is back in orbit, taking care of unfinished business.
3, 2, 1, 0, and liftoff of
Columbia roared into space on Tuesday for a 16-day space mission. It's a reflight of an April mission that had to be cut short because of problems with a power generator. The astronauts are studying fire and how flames spread in the near-zero gravity of space. They're also doing a variety of other experiments with an eye to a future when people spend long periods of time in space. And scientists' mission, and the ones planned for the future. This CD-ROM lets you launch a spacecraft to Mars, take a virtual tour of the planet, and practice moving the rover over the Martian landscape. It's the brainchild of a college professor and his students.
I'm really excited about this topic. It's aerospace engineering, astronomy, and most importantly, the missions to Mars.
Kurt Grimold is an educator who wants everyone to be as excited as he is about NASA's missions to Mars.
And the best thing about it is, it's a lot of fun. You get to play with million-dollar toys.
Grimold is one of many teachers around the country who've been enlisted by NASA's Jet Propulsion Lab for their educational outreach program. It gives students an idea what it's like to be a scientist tackling questions like, why did the water that once was on Mars disappear?
Now, that's the kind of question scientists love to have. Something that they can't explain, doesn't make any sense, but it makes a great career, trying to figure out why that happened.
Grimold used the talent and resources at hand at Georgia Tech to produce an interactive CD-ROM that could help answer questions about JPL, Mars, and the rest of the universe.
The CD-ROM was developed over a year ago for the purpose to get students, teachers more interested in space and be able to alert the K through 12 schools across the country of what is happening in the NASA and the Jet Propulsion laboratories in science.
Grimold recruited a group of Georgia Tech aerospace engineering students to help create the CD. He added multimedia skills to their engineering know-how. For some, it changed their lives and their career goals.
When I came to Tech, I never, in my wildest dreams, thought that I'd be doing this for a living. And it happened so quickly. In the course of 1 quarter at Tech, when I took the elective class, totally changed my outlook.
NASA's hoping that students who use the Mars Navigator CD will be attracted by built-in challenges like maneuvering the Mars rover on the red planet's surface.
We have a delay on it, so it doesn't read to a new... Oh, well, it crashed into a crater, so I guess I gotta go back.
The CD also surprises users with a rare look behind the scenes for advice from the experts.
When you go to school, don't worry about memorizing specific facts or equations. Worry about learning how to learn and being interested in a multitude of different subjects.
JPL scientists wanted the CD to explain the basics of space exploration and astronomy with lively animations and text.
and liftoff.
Once you understand those concepts, then your whole perception about your universe around you kind of changes a little bit. It becomes something more reachable.
In fact, one part of the program lets users reach out and touch the planets, arranging them in any order around the sun. If your solar system matches the real one, the CD is already in the hands of thousands of students and teachers across the country, and more copies are available from the Jet Propulsion Laboratory.
Welcome to Early Prime. I'm Lyndon Souls in Atlanta. Gene Meserve has the day off. We begin 120 million miles from Earth on the planet Mars. There, NASA's Pathfinder spacecraft is sending back spectacular pictures of the planet's surface. But a communications glitch threatens to derail a main goal of the mission. CNN's Jim Hill reports.
Scientists and engineers are patting each other on the back over the latest pictures they've received from Mars. At the same time, they're scratching their heads over a problem with the six-wheeled rover. It's only had partial communication with the lander, apparently because of a problem in the rover's computer modem.
The rover team worked very hard last night to look at various options. What can we do? There's a lot of things that we can do to fix these things. It's amazing what you can do from 120 million miles away.
Even if the problem cannot be solved, the rover can still creep off the lander and explore some of the Martian terrain on its own.
The rover has automatic software on board where once it is freed and the ramps are deployed, the rover will in fact drive down those ramps on its own without the help of the lander or without the help of our rover drivers here at JPL.
But engineers want to command or drive the rover themselves so they can analyze specific rocks and areas of Martian soil.
There's definitely two different types of soil here. That may be that some of the soil is brought in by a wind process and dropped onto this scene and therefore isn't really native to this area. Or it may be for some other reason.
The clear, sharp pictures also show there seem to be different kinds of rock. In one area, they're slanted in the same northwesterly direction, perhaps confirming that a flood swept through the region. Also, hills can be seen on the Martian horizon, and the rim of a deep crater lies only a couple of miles away.
The most mysterious thing in this picture is this little object on the horizon that has been likened to a couch. Somebody suggested there was a homeless person camped out there.
The Pathfinder team is obviously in good spirits, confident, and excited about the information it's received. And of course, its mission is far from over. Jim Hill, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
And for the very latest now on the Pathfinder mission, we go live to Pasadena and CNN's John Zarella. John, the mission controllers are saying that the communication situation is degraded and not lost entirely. What's the status of the situation right now?
Lyndon, just a few minutes ago, I was talking to one of the chief scientists here at the Jet Propulsion Laboratory, and he said to me, he said, you know, this is what exploration is all about. If you're not pushing the envelope, if you're not pushing the limits, if you don't have problems, then you're not really doing exploration. And that's what they're out there now doing, testing all new technologies that have never been used before. And what they are doing now is they've sent commands up to the spacecraft, to the lander, and they are waiting to get information back. And that should come in about an hour and a half. When they get that information, that downlink back, they will know whether the ramp has been deployed and whether the rover has stood up. The rover can't do anything unless they can get it to stand up. So that's a very critical thing that's going to happen in the next couple hours. They'll find out if indeed that happened. If not, they plan to send some more commands up and try and get the rover to execute those commands. If all that happens as we progress through the evening, later this evening, the rover will finally get off of the ramp. The rover will then take pictures of the lander. And then we will really get the geologists tantalized as they will finally be able to get some samplings of some rocks that they really want to get that rover over there to so that it can start using that spectrometer it has and sniffing those rocks and doing chemical analysis. They're very confident here. They do believe they can work these glitches out. After all, they sent this spacecraft 120 million miles, as you pointed out, which was no small task, and managed to do some phenomenal work up to this point. Now, this has to be considered a successful mission, they say. Early on in the project, they were telling me that if they just landed on Mars safely, if they just got one picture back, this would be a successful mission. So already, Lyndon, they have far exceeded any of their goals, although obviously as scientists who are pushing the envelope, they want to get that rover off. It is the centerpiece of this mission, and we're going to be building up to some exciting moments throughout the day and evening today. Lyndon?
What else are they hoping for in terms of changing conditions that may help them with the reestablishment of that communications link, John?
Well, what we have now is that the sun has come up on Mars, so they're getting the heating of the day, and they are also then able to get the solar batteries charged up. The vehicle basically goes to sleep during the Martian night, and now it's awake. And also the Earth, which is a morning star in Mars, has risen a few hours ago, which will make it better and better for them to communicate with the vehicle on Mars. Hard to believe we're saying that, talking to Mars, but that's exactly what they're doing. And as with the Earth rise and the sun rise, it makes it much, much easier for them to send these commands and to get the signals. This is a Mars day, so this is the timetable that they are working on right now. Lyndon?
Well, we're going to be holding our breath along with all the folks at NASA. John, thanks very much.
Indeed.
CNN's John Zarella in Pasadena. NASA plans a news conference in a few hours to give us an update on the Pathfinder, and you can catch it right here. CNN's live coverage begins at 8 p.m. Eastern, 5 Pacific. Revelation crew heard a thumping sound Tuesday and saw something leaking out of the damaged Spectre module. A rocket launched early Saturday is carrying equipment the Mir crew will use to repair the Spectre from the inside. But NASA says the incident Tuesday is raising concerns about the spacesuit mission into the module. The module lost pressure last month in a collision with a supply craft. The shuttle Columbia is in orbit as well, and Saturday the mission commander spoke by radio with fellow U.S. astronaut Michael Foale aboard Mir. Commander James Halsell says Foale sounds in fantastic spirits. Eastern on Prime News, NASA's search for life on Mars hit some roadblocks. We'll have an update on Pathfinder's progress and on the Mir space station at 8 p.m. Eastern, 5 Pacific. And that... A mysterious thump in space. What's happening aboard Mir now? Meanwhile, on Mars...
A condition in which communication between the rover and the lander is degraded. We're hearing each other, but we're just kind of getting... one syllable.
What to do? You can't start the car and you're out in the middle of nowhere, millions of miles from home. Plus, this. And World Headquarters in Atlanta, welcome to Worldview. Gene Meserve is off today. It is a busy weekend in space. Right now, the troubled Russian space station Mir is awaiting the arrival of a cargo ship launched by Russia Saturday. It's carrying supplies to repair the station, damaged 10 days ago in a collision with another cargo ship. The head of NASA's Shuttle Mir program says he wants to make sure the Mir crew is not endangered during the repairs by an unknown substance that spilled inside one of the modules during the collision.
The crew observed something that looked like snowflakes or something emitting from the area of the radiator that was damaged during the collision. That could be a number of things. It could be something coming from inside the Spectre through whatever hole there is in the hull. It could have been an experiment that burst or something like that produced some kind of liquid that then drifted into the hole and out into space.
The supply ship launched Saturday is scheduled to rendezvous with Mir on Monday. We get details from CNN's Jill Doherty in Moscow.
The Progress M35 cargo ship blasted off from Baikonur Space Complex in Kazakhstan. 10 minutes later, it was in orbit around the Earth, scheduled to dock with the Mir space station Monday. At mission control outside Moscow, cheers and applause as scientists and officials monitored the launch on a large screen.
On a whole, the complex has been working very well since we corrected the problems with the movement orientation system, the climatic conditions, the humidity conditions, the electricity. That's all up to norm, and the complex has been prepared for a docking process with a Progress ship.
The cargo ship is loaded with more than 2 tons of repair supplies. The most important piece, a new custom-made hatch the Mir crew will install on the damaged Spectre module. Also aboard, half a ton of fuel for Mir, more food and water for the crew, personal supplies and underwear, as well as more scientific equipment for a French astronaut who's scheduled to join Mir this August. The Mir crew was given an additional 6 or 7 days to practice for the repair job they'll carry out on the damaged Spectre module mid-July. The Russian commander, dressed in a spacesuit, will have to enter the depressurized module and reconnect several cables from the solar panels back through the new hatch to the Mir's power system. Russian scientists say it's complex, but can be done.
It's not an easy task, and always it's some part of a day in danger in connection with every spacewalk. But they performed it, or cosmonaut performed it many times.
Monday's docking of the supply ship is a similar procedure to what caused the Mir collision in the first place. But this time the crew will be docking it automatically instead of manually. Scientists are keeping their fingers crossed. Jill Doherty, CNN, Moscow.
It's a little like a tot in a candy store who can reach the counter but not the sweets. Unless NASA can figure out a communications glitch, it may not get its Mars rover to the rocks and Martian soil scientists so want to analyze. CNN's John Zarella joins us now live in Pasadena, California, home to NASA's Jet Propulsion Laboratory. John, I guess we should clarify that the scientists may not get to specific rocks, but the rover will indeed get out roving.
That's exactly right. And I have to say that they are very, very optimistic that they will get the rover off. And in about 20 minutes, or less than that now, about 15 minutes, we should have some good information as to what happened. That's when they will receive information as to whether the ramp has been deployed, that communications have been received by the spacecraft, and that the ramp is deployed, and that the rover is now standing up. You can see there in the animation, they have to have the rover standing up before it can do anything. If it doesn't stand up, it won't do that. Go off of that ramp. Should know again in about 15-20 minutes as the folks here at Jet Propulsion Laboratory get the information. You can see there the rover is out and it is roaming around there in that animation. And what happens is the rover can automatically take off and on its own if they don't command it. And it will do that eventually, probably I guess in the next day or so. But they believe that they can get this problem worked out. Now some of the video, the pictures that they got back yesterday, they enhanced them last night and released them this morning at a briefing, and it's a panoramic view, and there's the rover with the airbags, and that was before the fix on those airbags. The airbags are not a problem anymore. They've solved that by raising the pedal and then retracting the airbags a little bit more, and they got them tucked underneath enough so that they will be able to get the ramps down, and they hope that that has in fact happened. Joining us now is Dr. Matthew Golombek, the project's chief scientist. And Matthew, you look at that panoramic view, and I know the scientists are just chomping at the bit, aren't they?
My heart soars when I see that. I mean, that is a spectacular view. We've got mountains in the background. We have what look like a whole variety of different rocks with colors and textures and different kind of soil material. It's everything we could have possibly hoped for on Mars.
How does this site compare to the Viking sites?
Oh, it's so much more interesting. To give you an example, we have figured out where we have landed in one day. At Viking 1, it took them a year to figure out where they landed, and at Viking 2, they never figured out where they landed. We did it in one day. At both of the previous sites, there was nothing on the horizon. The relief was very, very low. They were extremely flat places. We've got mountains and hills in the background that we've enhanced, and it looks like we see layers in them. Spectacular stuff to see. And then looking at the rocks at Vikings 1 and 2 were all pretty much the same. You just couldn't see anything that looked very different. We have a whole variety of different things. We're already seeing differences in colors, in textures. There looks like there's layering in some rocks. There's that one flat-topped rock and what are those? We gotta go see them.
That's the couch, right?
No, the one right up front.
Oh, the one up front.
It looks like it's on a bedding plane.
Yes.
It looks like, is that a layered rock? What a find if it was. So we're just so excited. We have 70 of the most excited scientists you could possibly want.
Have you picked out a first and second target once you get the rover off?
Oh, yes. And then remember, this isn't just a science. It's a combination of where the rover can go and where it can get to. And we've identified, if we go off the front ramp as we think, we'll do a soil measurement the first night, and then we'll go towards a very dark rock that's sitting just, maybe a meter or so away, that it looks like it's easy to get to, it's big enough to get the APXS down on, and it doesn't have dust on it. We don't want to measure the dust, because that's probably uniform around the planet. We want to look at the native rock. And so it's waiting for us.
This will happen possibly tonight. Is there a chance, or is it going to be another day before you can do that?
We have a chance of getting the rover off the ramp today and of getting a soil measurement, which will be the first really good measurement on Mars ever, really, given the kind of resolution we have compared to Viking. And then maybe the next day we would go for the rock.
So on Sunday, if things proceed, and you are confident that they're going to solve this communications problem.
Oh, these engineers are aces. They are sharp. This is trivial. They are going to fix this. We're going to be on our way in no time. Everything has gone just perfectly. We've done, I think I told you, about a dozen operational readiness tests in the laboratory here, and we have never had everything work as perfectly as it did yesterday. A stunning success.
Matthew, thank you very much for joining us again.
Welcome.
He has a very, very busy schedule behind him that he finished up and ahead of him, and he's always been very gracious to join us here. And of course, they had always said that if they just got on Mars and if they got one picture back, this would be successful, this mission, and it has far, far exceeded that. Lyndon?
Gee, do you think Matthew sounds just a little bit excited? John, thanks very much.
Just a little bit.
CNN's John Zarella in Pasadena, California. Thank you. And Stern, the machine is on one planet, the repairman on another. And we're also getting reports that the Pathfinder is now sending back data to Earth. We'll bring you live a NASA news conference on the status of the Pathfinder Mars mission, 8 Eastern, 5 Pacific.
We have rover data. Yeah!
A message from the Red Planet inspires cheers and a big sigh of relief on Earth as NASA works feverishly to restore contact on Mars with the Sojourner rover and salvage its outer space journey. At CNN Center in Atlanta, I'm Lyndon Souls. Welcome to Prime News. We are standing by for a scheduled NASA briefing on the Mars mission. We'll bring that to you live as soon as it begins. Anxiety has given way to exhilaration for the scientists now that they've remedied a potentially crippling communication problem with the Mars Pathfinder and its robot rover. CNN's John Zarella has been following the story. He joins us now live from NASA's Jet Propulsion Laboratory in Pasadena, California. Hi, John.
Good evening, Lyndon. We understand that the briefing has already begun, so we're going to take you right inside and let you hear what the scientists have to say.
Minutes a day. Today, this afternoon, over at the Planet Fest at the Pasadena Civic Auditorium, I had the pleasure, extreme honor, of participating with Dan Golden and Carl's wife, Annie Druyan, naming the Mars Pathfinder lander the Sagan Memorial Station. Very fitting. Not only did Sagan inspire the general public, he spent a lot of time here at JPL. He was a participating scientist on many of the missions, and he inspired all of us rocket scientists here at JPL as well. Once I was on an agenda. There was this agenda, and it was all printed out. Tony Spears on the agenda making a presentation, and Carl Sagan was making a presentation. I was so excited about that, I almost forgot what I was going to say. Over the last couple days, we're verging on near miracles, okay? That my wonderful team, led by Cookie here, Richard Cook, and I'm wondering if Carl Sagan is not looking down on us, smiling, having fun. Maybe he had a hand in a couple of these events that have happened over the last day and a half. So that's all I have to say. I'm very proud that now Mars Pathfinder lander is the Sagan Memorial Station.
Okay, well, I think our excitement continues today. For those of you who've been listening in on the VoiceNet, you can tell that this morning has been an interesting, or this afternoon has been an interesting afternoon already. We've just completed a transmit downlink session on the spacecraft in which we got a number of interesting results, led by the fact that we're now receiving communications from the rover. Matt will discuss that in a minute here. But in addition, we have discovered that during the night last night, actually right at the end of the activities on Sol 1, so at about 10:30 last night here in Pasadena, the spacecraft flight computer reset. And what happens when a reset occurs is the spacecraft essentially terminates all of the sequences which it's running and goes into a kind of a, not really a safe mode, but essentially sort of just turns on some of the receiver and the flight computer and just basically sits there and waits for the Earth to come along and tell it what to do. Normally, we would not have known that activity took place because we would have expected the communications from the spacecraft in the morning and not received it. But as it turns out, in order to troubleshoot the rover problems, we scheduled a special downlink this morning, which was performed nominally, and so we got the data back which said that this reset had occurred. The spacecraft is fine. The lander's fine. It essentially operated all night just as it was supposed to, and we got the data back telling us that that all of the subsystems were performing fine. But we're a little perplexed as to what happened, and so we're right now, hopefully, we are transmitting commands to the spacecraft that tell it to start a new downlink session in which we're going to send some more diagnostic data down. And then we should be able to figure out what happened. But essentially, it did not adversely impact us really in any way. But we do want to understand what happened. But overall, because of the fact that we also this morning received additional images of the area behind where the rover is sitting, we feel like we're actually, once we get this next set of data down, that we're really able to then go on with the remainder of the day's activities, picking up essentially where we left off yesterday with the ramp deploy and eventual rover egress. So I think that's it. I'll let Matt talk about what they've learned from the rover side.
Richard. As I said a little earlier, we feel like somebody just invited us back to the party. We've got, as most of you are aware, we had an issue last night with the rover communications and the lander where we had a degradation of our communications link. The rover team got together and valiantly worked through the night. They came up with a number of possible scenarios, and they developed a list of potential fixes for those scenarios. And we implemented a number of those this morning, actually just before the downlink. And when the downlink started, as you just heard Richard mention, we did in fact receive good rover to lander communications. And all the indications are that the rover was in fact doing exactly what it should have done, which was to perform its run-out sequence from yesterday and wait for new commands. It did receive a new sequence from us this morning, which essentially told it to continue to communicate with the lander and to wait for further instructions. And so that's where we're at with the rover. The team, I can tell you, is extremely pleased. There are a few touchdown dances done, I think, when we got that information. And we're ready to move forward here and get the rover stood up and egress down the ramp.
Okay, we'll go to Q&A momentarily. First, I just wanted to mention that we're going to be discussing with the project plans for our 9 p.m. press briefing tonight. It's possible that we may not really have significant new data to release then, so that briefing may be canceled. But please check with the newsroom to see what the status on that is. And the team's under a very tight deadline, so we'll try to move very quickly with our questions. Let's see, can we get one to John Wilford?
John Wilford, New York Times. If there's not a briefing at 9 o'clock, what happens if the rover goes out? Will we get some feed on that at that time? Or could you go over, has there been any change in the timing for stand-up, ramp, egress, and all those things?
The The plan is still to, presuming that we get information back in this next downlink, which looks good, and tells us what happened, and I think we will, we should be able to move forward with ramp deployment in the next hour or so after that, hour to 2 hours. And then actual rover egress could occur 2 to 3 hours after that. So we're
3 hours after what?
After the ramp deploy.
What? Give me just round figures. I want to know if
6:30, 7 o'clock.
What?
About 7 o'clock.
7 o'clock is ramp, and 3 hours later.
2 to 3 hours later after that would be rover.
And just to answer your question about how we would communicate that to you, we will in any case have commentated mission coverage on the video monitors running until 12 midnight Pacific time. So you'll be able to check the status that way.
I don't need to add that, I'm sure you guys you've already convinced you over the last day and a half that things are somewhat uncertain and that things will happen at the rate at which they're going to happen. So that's just my guess, but at this point, we'll have to see how things go.
Andrew?
Andy Chaikin, Popular Science. I just want to make sure I understand what you think happened to clear up the problem with the modem, the communications. There were two things that you mentioned. One was that the lander's computer reset itself, and was that what cleared it up? And the other thing you mentioned was that the rover received commands that you sent last night, and what role did that have in clearing it up?
Okay, let me clarify that a little bit. The telemetry that we got this morning, we're still looking at to understand exactly which of the potential fixes that we implemented actually was what allowed us to open up that communications channel with the lander. And so we're still really a little uncertain as to what in fact was what ultimately gave us the ability to communicate again with the lander successfully. But right now we're at about an 80% success rate. A couple of possibilities, one of which is that the modem or the hardware that the computer uses to interface with the modem, either on the lander side or on the rover side. These actually are identical on both sides of the interface. There's a possibility that a piece of that hardware hung, something like your computer would hang when you're working on it, and that the shutdown of the rover overnight, which is a normal thing for us to do, would have cleared that up. That's one possibility. We also switched the power supply on the lander side to the modem. We have essentially one modem on the lander, and we have two power supplies. So we switched the power supply to that modem. That may also have been what cleared up the communication degradation. And there are one or two other, perhaps less likely possibilities. But we're going to need to take some time to look at our data and at the lander's data to really know for sure.
Okay, William?
Yes, William Boyer for Space News. So is it at this point you really don't know what caused the problem, so you don't really know if it's going to happen again in the future? And then is this fail-safe mode for the rover, is the clock still running on that and it's potentially going to start doing its own thing? You talked last night about how it would go and just deploy itself automatically.
Yeah, that's right. Well, until we understand which fix it was that actually corrected the degradation in the communication link, we're not going to know for sure what the cause was. But clearly, if it was correctable once, we feel like there's very high probability we could correct it again. And relative to the contingency sequence, since we have now received a new sequence on board the rover, the one which we uplinked just before this lander downlink, that to some degree has reset that counter. However, it's always hovering there in the background. In the event that something happens down the line on the rover, it will actually implement and carry on with the rover mission.
Yeah, Paul Wolferston, USA Today. Richard, in between sunrise and sunset, Earthrise and Earthset and all these times, how many hours a day, Earth hours, does it work out that you're actually in two-way communication with the lander?
That we're getting, the times at which the spacecraft is transmitting data to us is relatively short every day, between 2 and 3 hours. We are usually transmitting to the spacecraft all the time between Earthrise and Earthset, or at least as much time as we have DSN station coverage, which sometimes isn't continuous. But for the first couple days, it's been continuous from Earthrise to Earthset. That's about 12 hours.
Key Davidson, San Francisco Examiner. This morning there was some discussion by Paul Smith about an interesting looking object quite a ways in the distance that some people have compared to a couch or an old seat cushion or whatever. Assuming that all goes well with the rover, is the rover capable of traveling whatever distance it is to that object and getting a better look at it?
Well, with the other issues that we've been dealing with, actually over the last day or two, we haven't had a lot of time to, view the scenery, so to speak. Yeah. We're gonna start doing that sort of thing now, obviously, and looking at potential rover targets and operations areas. And for the first couple days, we'll really just have a learner's permit relative to driving the rover. It'll take us a couple days to get our sea legs, and then we'll start to venture out a little farther away from the lander. How far we go really depends on how long the rover mission lasts, I think.
But isn't it true, we're talking about tens of meters, most likely, how far the rover gets away.
Okay, one back here.
Yeah, I'd like to ask the three of you to maybe look back upon the most concerned moment you had in the last 12 hours. What were your fears when there wasn't this direct link with Sojourner? How nervous were you, and what was the mood at Mission Control?
I think the mood has always been optimistic. I mean, particularly after yesterday when we had so many things go right. I mean, it was like, we need to persevere here and things will take care of themselves. It's been, I've mentioned many times over the last few days that this is somewhat of a ride, a wild ride for the flight team. And I mean, there is a lot of stuff that's happening and it's pretty dynamic and actually it's really fun. I mean, this is really what we're here for. I suspect that when we get the rover off, that things will settle kind of down and be a little less dramatic, and in a sense we'll miss these first few days. So we're all up there having fun. I don't think anybody is really down in the dumps or depressed or anything.
You know what I sense hanging around up there is no one thought anything broke, and everybody was confident that we're going to fix it, and so we weren't really that down. As a matter of fact, we were very up.
Irene?
Once the rover mission began, was it in constant communication with the lander, or was it data taped and then relayed at specific intervals? And then, just one other question about the rover mission for tonight. Once it's off the ramp, exactly what do you propose to do with it tonight?
Okay, your first question. The rover typically will attempt to communicate with the lander during daylight hours on Mars about once a minute. So it's very frequent communication. It goes and looks for new instructions essentially about once a minute. At nighttime, however, to conserve power, we typically will command the rover to shut down and to hibernate, sleep, and wake up typically once an hour to do just sort of a check with the lander to tell the lander that we're still here and we're still okay. Relative to what we're going to do this afternoon and tonight, most likely, if we get to the point where we have a successful ramp deployment and egress, we'll just drive down the ramp. We may do a small turn, but very little other than that. And then we'll drop our spectrometer, which is on the rear side of the rover, down onto the soil and start to take some overnight measurements of the soil.
Joe?
Joe Palka from National Public Radio. Have you made any plans yet of when you'll deploy the IMP mast?
Right now, the plan is to do it late this afternoon, Mars time, late this evening here. That'll be actually after rover deploy. It'll be around 11 o'clock tonight. So we won't actually get images back from the deployed position until tomorrow. At the earliest.
Todd Halverson of Florida Today. I think you guys were going to take the insurance panorama with the IMP today, and I was wondering when that panorama would be coming down, if it is in fact coming down.
Actually, the plan is to take those images right before we deploy the camera, and so it'll occur fairly late this evening. Those images, because they're, quote, insurance pans, aren't really high priority once we deploy the camera on its mast. And so what really will happen if we follow the normal plan that we have is tomorrow we would acquire some more interesting stereo imaging, which would in fact jump in front of that in the queue. The only reason why we may begin to get some of that is that in fact we're able to support much higher data rates than we were using in planning. Right now we're at about 4740 bits per second, which we probably can turn that up a little bit as well and go up to the next, at least probably the next higher data rate than that. So in fact we may end up getting some of that insurance data back as soon as tomorrow.
Okay, the team's on a tight schedule. Let's just take a couple more questions back here, and then we'll get Kelly and wrap up.
Fred Villanueva with KTLA TV. You have better technology as far as camera lenses and so forth now, which gives you more accurate pictures and better color, more accurate colors and so forth. What will the improved pictures be able to tell you from 21 years ago, as far as lenses are concerned, what you're seeing?
That's probably a better question to ask Peter Smith, really. I'm not sure I'm the best person to answer it. I think that probably the biggest single advantage is the number of color filters, actually. It's not necessarily the resolution of the camera per se, but it's the fact that each one of the eyes, so to speak, has 12 filters on it, so we can get a lot more spectral information from the camera than let's say the Viking camera would be. But I guess I would kind of defer that to have you talk to Peter about it.
All right, well, that has been a briefing here by the NASA engineering team of the Mars Pathfinder program. And basically what they're telling us is they're taking their time. They're not going to rush things. In the next couple of hours, we should know if we have ramp deploy. And then about 3 hours after that, we should know if they were able to get the rover off of the ramp. That will probably be the extent of the activities today, but things are certainly looking up. Donna Shirley.
Yes, they are.
They are looking very good. A very good chance then tonight. The rover's off the ramp. What are they doing right now? Why are they being so cautious?
Well, they're being cautious because we don't understand what happened last night. And so rather than rush into anything, they want to be sure that they understand the condition of the rover. They want to understand as much as they can why whatever happened last night happened, and they want to make sure that what they're going to do is the right thing to do. So they're diagnosing the data from last night, sort of poring over it to try to understand what it means. They're also busily planning what to do next, and there's several options that they have. For instance, they know that the alpha proton X-ray spectrometer has already been released, that apparently some of the rover release has taken place because they've got data that shows that. And so, but the ramps are still rolled up. So now they're trying to decide, do they unroll the ramps first? Do they unroll just the front ramp or just the back ramp or both? Do they stand up before they unroll the ramps, or do they unroll the ramps first? So they're trying to make decisions like that are going to maximize the chances of a successful rover deployment.
And you've got to get the rover to stand up before it goes anywhere, correct?
Right, absolutely. It has to stand up, and it's right down like this, and these are the rocker bogies, let's say, which are the levers that hold the wheels. And what happens when it stands up is there's a wheel here and a wheel here, and it drives those wheels together so that this flexes up and then click, latches into place. And that's what they want to make sure happens. So they want to make sure they understand the configuration of the rover exactly before they do that drive up.
Now, there's been a lot of talk that the rover might only last a week on the surface of Mars.
Right.
The mission was scheduled for a week. But this delay doesn't mean in 5 or 6 days now the rover's going to stop working.
No, the week was chosen for mission design purposes. We had to pick something. So we said, okay, let's try, just to make sure that we can get what we need to get done before anything could possibly happen to the rover. Let's say a week. What can we get done in a week? So that drove us to want to get the rover off very quickly. Now later we discovered that the lander wanted to get rid of the rover just as bad as the rover wanted to get off the lander, because the rover's sitting on their solar panels, blocking some of the solar energy. So after a few days, if the rover doesn't get off, it may compromise the lander mission because it would be able to transmit less.
All right, Donna Shirley, thank you very much again for taking time in a very, very busy schedule to come here and join us. And Donna would also tell you that the rover has instructions to take off on its own if it doesn't get some commands after a predetermined amount of time. So they do want to get this taken care of and move on now and get the rover off so that the geologists can get out there and start getting all that great data from what they say is just a tremendous site that far outshines anything in the Viking lander sites from some 21 years ago. So from here at the Jet Propulsion Laboratory in Pasadena, California, this is John Zarella reporting live.
Big sigh of relief. John, thanks very much. And when we come back, we'll talk more about the Mars mission as well as 2 other missions in space right now with the editor of Space News. Please stay with us. Headquarters in Atlanta, Gene Meserve is off. Welcome to the World Today. NASA is gearing up for what it hopes will be an even closer look at the surface of the red planet Mars. After a long, tense day of trying to fix a communications glitch, scientists reported success just hours ago. CNN's John Zarella is following developments from Pasadena, California, and joins us now with the latest on yet another milestone of the mission. John?
Lyndon, it certainly looks as if in the next 30 minutes or so we should know that whether they have gotten the commands to the vehicle, whether the vehicle has actually unfurled the ramps and down those ramps at some point, perhaps later this evening. The engineers here hope later this evening the Sojourner rover will descend those ramps onto the Martian surface. That has not happened yet, and in about an hour from now we may get pictures that will confirm that the ramps are down. So those will be the next big milestones in about 30 minutes or so, and then again in about an hour. That's given the scientists and engineers here reason to be upbeat, and they expressed that this afternoon following one of the news briefings here when they unfurled a giant mosaic. It was taken with about 120 images, and you can see it there. They're holding it up. And that's about 120 images of the Martian surface, just each one a tile size shape, and they put those all together into that mosaic, a panoramic view, and you can see there, just fabulous. They've enhanced the pictures. Those are many of the pictures that we saw yesterday, the first pictures, but they have since been enhanced and look much, much crisper and clearer. And by looking at those pictures, the geologists here and the project scientists are just chomping at the bit to get the rover off the lander and get out there to take a look at those rocks. It is a fascinating, fascinating site, they say, far better than anything at either of the 2 Viking sites.
Well, we have figured out where we have landed in one day. At Viking 1, it took them a year to figure out where they landed, and at Viking 2, they never figured out where they landed. We did it in one day. At both of the previous sites, there was nothing on the horizon. The relief was very, very low. They were extremely flat places. We've got mountains and hills in the background that we've enhanced, and it looks like we see layers in them. Spectacular stuff to see.
Joining us now to discuss getting the rover off, and Matthew Gollenbeck, you heard him there. He's so animated all the time and so excited. They want to get out there, and Howard Eisen, one of the chief developers here of rover technology. And Howard, what does it look like now tonight? Looking good?
Oh, it looks fantastic, John. Everybody is very, very excited. We're going to have the rover standing up in less than about 15 minutes. We'll have confirmation in about a half an hour, and we'll get some images both of the ramps deployed and some images from the rover cameras of those deployed ramps. So we'll be able to plan which way we want to go off.
Did you ever figure out what went wrong, why you were having a communications glitch?
Well, what we did last night is we sent up a variety of commands last night and this morning to try out a bunch of different things, and one of them worked. So we don't know what it is, but at the moment we're very happy because apparently it worked.
Whatever it was did work, so there is a fix. It may not, it's a fix one way or the other.
That's right. We might have gotten lucky. We might have actually solved the problem, but at least we got through it. And if it does reoccur, which we certainly hope it doesn't, we can probably try the same things again.
So tonight, though, the key is get the rover off the ramp.
That's right. Get the rover off the lander entirely, set it down on the surface of Mars.
So tonight would be the first night pretty much in history that a autonomous vehicle has been on the surface of Mars.
That's our intention, to make history here.
And it will be a historic night tonight.
That's right. Keep watching.
What happens then tomorrow? Tomorrow you take your first big steps, for lack of another word.
That's right. Well, if all goes well tonight, we'll drive down the ramp, we'll put our science instrument down on the surface. So we're actually taking science measurements this evening. We'll get a picture of the rover in that state, and then we'll take that image plus images of the surrounding terrain and plan tomorrow's operations. So we'll get with the scientists, we'll look to see what are the interesting sites, and there are so many interesting sites. And tomorrow we'll do some real driving.
So the spectrometer will be down on the surface, hopefully tonight,
right. Collecting data
on the soil.
That's right.
That was the first intention.
That's right.
And then you'll go out tomorrow and look at some and get some close-ups of some rocks, obviously.
That's right. We'll go in search of the first rock.
You guys ready to do the driving now? That's got to be the fun part of this.
Yeah, our rover driver Brian Cooper is just itching to get started. But and we've all been looking at the terrain lately. There's so many interesting sites out there. There are areas we think we see sand dunes, areas we think we see windswept material. There are rocks, there's scabby ground where there's a rough ground like a lava flow that's covered lightly in other materials. There's so many interesting sites to go out and look at and drive on and scrape and image and put down the APXS and do lots of good things.
And everyone is well practiced on this. There's nothing out there in the landscape that's different than what you really practiced on. You knew what to expect.
Well, in fact, the landscape looks easier than most of the simulations we've run. There are certainly challenges out there, but there are areas in there that we can work.
Howard, thank you so much for taking time out. Good luck this evening getting the rover off the ramp. Of course, we will be here all evening, keeping you up to date as the events unfold, and some very dramatic events indeed still to come. It would be the first fully autonomous vehicle on the surface of another planet, and that should happen later this evening. This is John Zarella reporting live from Pasadena. Lyndon?
John, thanks very much. We appreciate it. There are new questions about damage to the space station Mir. Crew members reported hearing thumps and seeing something that resembled snowflakes leaking from the damaged Spectre module Tuesday. Mir was damaged June 25th in a collision with a cargo ship. NASA officials say the latest reports raise concerns about what's inside the damaged section of Mir and its impact on a planned internal spacewalk for repairs. A supply ship carrying repair equipment blasted off from Russia Saturday. It's scheduled to dock with Mir on Monday. Cosmonauts now are expected to make their internal spacewalk July 17th. The head of NASA's shuttle Mir program says everything possible is being considered to minimize the danger.
I believe the hazard you would most worry about is snagging on something you can't see and not being able to get free from it in a tight, confined space. And also, of course, you would worry about what type of cut hazards there might be, sharp edges that might cut into the suit. Since you normally do EVA outside where you've got lots of room to maneuver and can stay away from these things, you want to make sure the crew understands exactly where the hazardous areas are and where to stay away from so the suit does not get cut on anything. And that's something the Russians I know are actively looking at right now.
Shuttle Columbia's commander spoke by ham radio Saturday with astronaut Michael Foale aboard Mir. Commander Jim Halsell says Foale is in fantastic spirits. So much has been happening in outer space the past few days, you might be finding it a little hard to keep up. Well, we can help you out. You can check out the CNN Interactive website to learn more about the Pathfinder trip to Mars. And join CNN for a late edition tomorrow at noon Eastern when the guest will be NASA Administrator Daniel Golden. He'll discuss the Pathfinder mission, the shuttle, and the latest troubles with the Mir space station.
Fixed a communications problem with the U.S. Mars lander and its remote rover Sojourner. The rover hadn't been responding to signals, apparently because of a software glitch. The originally named Pathfinder spacecraft, meanwhile, has been renamed after the late space scientist Carl Sagan.
Welcome back to World News. A remote-control rover is being ready to explore Mars. Mission team members are expected to decide within the next 90 minutes or so when to have Sojourner roll down one of its ramps onto the surface of the red planet. This is a relief for scientists at the U.S. Space Agency, NASA, because the mission was nearly derailed by a communications glitch. CNN's John Zarella joins us now from the Jet Propulsion Laboratory in Pasadena, California. John.
Leon, certainly history about to be made here very, very shortly. In fact, it'll be the first time in the history of humankind that an autonomous vehicle has crawled across another planet. And that won't happen too many minutes from now, perhaps less than an hour. In fact, about 40 minutes ago, the folks here at the Jet Propulsion Laboratory got back some images from Mars that showed that the two ramps, the front and rear ramp, had been deployed. Some fabulous images. The rear ramp certainly looked very, very good. The front ramp was kind of interesting also because it seems to be suspended in space. And to explain exactly what's going to be happening from here on is Brian Cooper, rover driver. And Brian, you've already punched in all the computer program, and the vehicle is ready to do its thing as soon as the command is set?
Yeah, just a few minutes ago, the rover team and myself took a look at the images that we recently got, which shows the front ramp actually kind of floating in midair, and we expected it with the gravity to have it fall down. So that we've deemed that to be not safe. But the rear ramp looks fine, and it's looks like an easy drive down to the surface. And we created the sequence, including images that will be taken during and some other experiments. But what's going to happen is we'll take a look at this model here. This is Sojourner rover on the pedal as it is right now, and we've got confirmation that it stood up safely by looking at a close-up image of this mechanism. And this is the area. This is the rear of the vehicle, and we're going to back it off in the blind onto a ramp, which isn't on here, but it's safely going on down to onto the surface about a 25-degree angle. And we've given the command to do exactly what we say. Don't make any turns, and go straight down and land onto the surface and deploy the alpha proton X-ray spectrometer, which I'm pointing to right now, onto the soil so we can take a sample tonight.
So tonight you'll get, overnight, the spectrometer will be doing its thing, and you'll get your first real science of the soil of Mars tomorrow.
There's a lot of scientists, geologists just very excited about getting that information.
Then what happens? Then tomorrow will be the big day for actually, really for your team to start doing what you do best, moving the rover, targeting objects, and sending it off.
Right. What I'm looking forward to doing then is to take the rover in its position safely on the surface of Mars, put on my 3D goggles, and I look at my screen, and I can see that extra sense of depth, and I'll tell the rover where to go. And I'm taking inputs from the scientists. We have a big scientific team here, and we're probably going to go close and maybe taking a sample of a rock, which we have very near the end of the ramp. So the rover won't have to go very far to get to a rock.
You want to take those first baby steps, so to speak, don't you, before you make any long progression along the Martian soil?
Sure. Early on, we're gonna try to reduce our risk and stay near the lander, where we have the best resolution of the terrain and the rocks. So later on, as time progresses, we'll get more bold. We'll probably go more often in the horizon.
A little more comfortable also with the capability of the rover and your own capabilities to move it, right?
That's right. Well, although we've practiced a lot, I think we know how to drive it. There's some aspects we don't know about, and that's the soil characteristics of the surface and how the wheels will interact, how deep it'll sink. And so we'll have to, in real time, as we see it move, and we'll see the tracks and see how it performs, gauge that and allow us to better perform the next day.
Here you are just, moments perhaps away from a historic feat, and you're so calm. I'm sure everybody out there, all of our viewers...
It's just an illusion, really. We've been practicing this a lot, and it's allowed us to have a lot of confidence in our ability to do this. And so far, the system has performed very well. We had a little glitch yesterday, and this morning that was resolved, so now we're confident we can go and explore the surface.
Well, good luck. We certainly do wish all of you and the team the best of luck, and we are hoping that within a couple of hours, within perhaps an hour, the rover may be on the surface. Certainly not much longer than that if all goes well, and then we should have some images back within a couple of hours of the rover on the surface of Mars. Again, it would be an historic event, the first time an autonomous vehicle has crawled across the surface and set foot on the surface, or set wheels in this case, on the surface of another planet. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena. Back to you, Leon.
Thanks, John. Well, new questions have been raised about damage to the Russian space station Mir. U.S. space officials say that they're concerned about crew members' reports of flakes and bubbles leaking from the damaged Spectre module. They say the leak might affect the crew during repair efforts. The crew is awaiting the planned arrival on Monday of a Russian supply ship carrying repair equipment. The Progress cargo ship lifted off on Saturday. The problem was caused when a similar unmanned cargo ship collided with Mir on June 25th. Well, there's more.
The following is CNN's coverage of a live event.
everyone. I'm Catherine Calloway in Atlanta. An exciting night for NASA. We are expecting the first images of the Pathfinder on the surface of Mars. Let's go right to John Zarella, who is in Pasadena with the very latest on this. John?
Well, good evening. Indeed, NASA engineers are receiving a downlink right now from the lander, from the spacecraft on Mars, and during the course of this downlink, perhaps any minute, now you can see there inside Mission Control, they should be getting some pictures that will show them the Sojourner rover on the ground on Mars. It does not appear, now Donna Shirley, join in here when you can.
Okay.
It doesn't appear as if they have those images yet,
No, we don't
does
have
it?
them yet, but they should be, they have to, what the images do is they come down to the Earth and they're caught in a big, giant antenna. I don't know which one. It's either Goldstone, Madrid, Spain, or Canberra, Australia. And then they have to be shipped via satellite back here, so there's a little delay.
The Jet Propulsion Laboratory in Pasadena, California.
Go ahead, Rover. We are receiving data.
We are receiving data. Okay, so the rover data is coming back.
Seated is Flight Director Chris Salvo. They're laughing. It must be good news. In the colored shirt
they'd be
is
cheering.
Project Scientist Matt Gullenbeck. In front of him is Brian Muirhead. That's Matthew Gullenbeck on the left.
Right, and Brian Muirhead, the tall guy in the shirt.
We are
with a
going
blue
to
shirt.
let this
And Gordon Wood is the animated one on the right with the white shirt on.
In this high gain session that we
Gordon Wood is the telecommunications engineer who told us that we weren't going to hear anything after we entered.
And then you heard it all the way down.
And then we heard it all the way down.
And they were saying they're going to let us listen real time as this entire, if I caught the drift of what he was saying, as this entire event here is unfolding, this downlink of data and images from the Pathfinder vehicle. Now, the first images you will get will be taken from the lander of the vehicle on the surface of Mars,
That's
correct?
correct.
Sojourner.
That's correct. And I'm not sure whether we will actually see any images taken by the rover's cameras or not. They may decide to take it because they may put the alpha proton X-ray spectrometer right down on the ground without sending any more commands, and then they like to take a picture of that to see where it is. And the rover's rear camera, there's a little color camera on the rear that's got a very wide angle lens, and so it can actually see the ground and back of the rover.
Right, APS.
And
Go ahead, APS. Did you guys put in the sequence?
No, they're just
there's pictures now.
Okay, there's a picture. All right. Let's see. Well, there's, that's the sun.
That's the sun.
Yeah.
In the upper left-hand corner.
Right. Peter Smith. So a lot of these pictures, now you can see on this chart, you see this little circle on the bottom here?
Right, the circle in the bottom middle for the viewers.
And then there's a kind of a ray going out from it.
See the ray moving.
And that's the direction that the camera is pointing. And now, these, I found out what these are. Yesterday I didn't know. Those are the magnetic targets. And those are the ones that are going to be attracting dirt, the magnetized dust, and they will stick to those targets. And these targets are different levels of magnification, so that if they have more dust on them, they're a stronger magnet. On Viking, they had some strong magnets, and the dust immediately went zoop and completely covered them. So there's a gradation of these magnets from strong to weak.
Any image here could pop up a picture.
That's right. You can't
We just don't know, but any
That's
picture now, we could see Sojourner on the surface of the planet.
Right.
And
because they don't just march around nicely around the circle. They come in at random somehow.
That will be historic.
Yes.
Once again, another historic event.
I'm watching.
The first autonomous vehicle.
These pictures don't come in all at once either. I mean, you get a bunch, and then they kind of wait and send in some more data, and then you get another bunch.
There's a tighter shot of that.
Right, and that one's shinier too.
Yes.
I don't know if I can see I can't with my eye see any particular.
Now, for the viewers out there, if they're looking down at that center disc with the 3 pedals in it, the Sojourner rover is actually on the pedal that would be facing 3 o'clock. Is that correct?
However, it will now have backed off, and so it will actually be more like at 4 o'clock.
At 4 o'clock.
All right, that rover UART error handler message is nominal at this time. It's expected.
Continuing to show these same photos. So again, as we are going through this sequence, no order in which they're coming in.
Well, I don't know the order. There's some rational thought behind this. I just don't know it.
Do they?
Oh, see, now there's that one looks like it's a little farther away. But they got rover data, which means that the rover is talking to the lander.
Phenomenal.
So the rover's communicating. That means the rover's communication system is in good order. And there were some problems with that earlier. If you recall yesterday, there were some problems with that. So it seems to be in good shape today.
So the rover should be on the surface of Mars right now.
Right now.
And this is just confirmation of an event that's already taken place.
That's right. That's right. Now these images are from a little different angle according to the circle, but they look the same.
When we were talking earlier to Brian Cooper, rover driver, and Brian was saying that one of the interesting things, and you had mentioned it to me earlier as well, is that the landing ramp on the front is suspended in midair.
Right.
It's actually floating because the Martian atmosphere is so thick. Didn't fall all the way?
Gravity.
I mean the gravity.
Right.
It did not fall all the way.
That's right, because we designed these things to be stiff enough to support the rover when it's running down the ramps. And in this case, it was just stiff enough that it didn't actually fall down. Now, the rover only weighs 9 pounds on Mars. On Earth, it weighs around 22 or 23 pounds.
Here's a look at the animation of what should have taken place.
Right. Except that in this animation, the rover is going down frontwards.
Right.
The real one is going down backwards.
Is going down backwards.
Now, you want to know why it's going down backwards,
Yes,
I bet.
indeed.
The reason it's going down backwards, there's 3 reasons. One is that front ramp is up in the air, and the rover's weight would easily push the ramp down, no problem. But when the ramp dropped, the rover's software would say, whoop, something's wrong here, and it would stop. And so we don't want the rover to stop at the top of the ramp.
We're getting a whole slew of rover image engineering packet.
Rover
image engineering. That means there's
from a previous sequence.
That means that there is actually the rover is sending the pictures that its cameras took, which are different than the pictures that the lander camera took.
These are rover images, then?
No, not these. Not these. See, we're still getting getting lander images. Rover images would be of dirt, I imagine, and you'd see a wheel in them probably.
Let me ask you then, when we are now looking at a continuation of these frames coming down of an event that's already happened on the surface of Mars, as far as we know, then the vehicle Sojourner is there. It's sitting
already there. But this is a confirmation of that. We don't want to take it on faith.
One of the concerns that was expressed also, even about going off the backside, was that there was still a little bit of that air of the airbag encroaching on the side of the ramp.
Right, and I believe they ran some tests. Well, they did run some tests last week to make sure that even if the ramps didn't deploy at all, or if there were big rocks stuck up against the pedals, that the rover could actually turn and go over the solar panels and clamber over the airbags and get onto the surface. And they tested that, and it was able to do it. Not something we want to do. But for one thing, it scratches the solar panels on the lander, which the lander doesn't like a lot.
Earlier this evening, I noticed that they were testing in the sandbox the procedure for the rover to be going down this ramp before they sent the command for it to do so.
Right.
Can you tell
That's what we have the sandbox for, is to practice these things. And so in this case, there was just a little bit of airbag lopped over onto the ramp. And the engineers were fairly confident that there wouldn't be any problem because the airbags we have here in the test bed are really old and beat up and stretched and scratched and threadbare. And if the cleats on the wheels are going to catch, they're going to catch in that old airbag material. The airbags on Mars are nice and new and fresh and stiff, and so we expected that the rover would just roll right over it without any problem. Well, we just seem to be getting a lot of these magnetic images here. So let me tell you about why it's going backwards.
Yes.
I said one time the ramp in the front is up, so we don't want to do that. Number 2, the airbags are bunched up in such a way that if the ramp in the front were on the ground, we wouldn't be able to see very well. Oh, there's the back ramp. Okay. No rover. Whoop. Ah, drat. that was the back ramp. So the rover, if it's off the ramp, is farther out.
Further out
than that.
That would be the ramp the rover should have gone down.
The ramp the rover should have gone down. So the rover is probably off.
We're receiving imaging of the rover at the bottom of the ramp.
Say rover at the bottom of the ramp.
Well, I don't see a rover in that picture.
There's no rover yet. There is no rover in those images yet.
There is no rover in those images
Do you see any rover tire tracks or anything?
No, I can't tell.
Can't tell.
In this view.
This is the same image again and again,
Yeah.
it appears.
They're just taking it in different filters because they want to be able to tell the different colors. And so what's going on is he's taking this in just all kinds of different filters. And there's 12 different filters, remember. There's probably 20 or 30 images in each one of these things. And we don't know when. We know the rover isn't stuck on the ramp. Now, that we do know from this picture.
It's not on the ramp,
Right.
but do we know that it's actually gone off the ramp? I mean, it could still be sitting on the pedal then.
It could. That's right. We don't know yet. Although they'll be able to tell from the rover telemetry how many times the wheels have turned.
Would they already have that information
They
from the
have
earlier
it, but
packet?
they're processing it. There it is. It's on the ramp. It's on the ramp. It's sitting on the ramp. Okay, it hasn't gotten all the way off yet. All right, they'll just send another command to tell it to go on down.
So right now it is sitting on the ramp.
Almost at the end of the ramp. And so what happened there, I mean, I'll speculate. That what
Here it's
happened,
moving further off, though.
It's moving. Oh, okay, this is the movie. This is the movie.
The movie.
Yeah, this is a movie.
This is spectacular.
Okay, watch this. Here it goes.
2679 is complete, halfway down the ramp.
All right, there it goes. Okay, this is the same picture, just in a different filter.
Flight, we can confirm that our first move halfway down the ramp was successful with no errors.
Okay, so it's they have confirmation, besides the picture, that it was halfway down the ramp. Now, it still has to get all the way off. And so what they're going to do, I forgot that they did this during testing. They actually made a movie, click, 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 and they can run it as a movie, showing the rover getting down the ramp. So hang in there with us. We're going to get some more.
Some more images, a little further off, the first wheels off, and then finally the entire rover
off. But if it's this far, I'm real comfortable.
Moving.
Yeah,
I mean,
it's
moving,
it's functioning. Sojourner lives. And the back ramp is also good to go off because we can see the end of it, so we know that the terrain is safe to get off. And also there's this nice big knobbly rock right close to there. So what they want to do is they won't have to go very far to get the alpha proton X-ray spectrometer on the rock.
Was there ever any doubt in your mind? I know everyone here was so confident all day, even despite the fact that they had the communications glitch, but everyone we talked with, yourself included, was, we'll figure this out. This is not a showstopper.
Right. No, I was telling some of the people that I was on the Mariner 10 mission to Venus and Mercury, and everything that could possibly go wrong with that mission went wrong, and we still went by Mercury 3 times. I mean, everything went wrong, and it took just this incredible ingenuity and hard work of the team to make it go. So that's JPL's specialty. Oh, that's the ASI mast. That's the weather mast.
The weather mast with the windsock?
Just over the little blip on the left, about halfway up, is the windsock.
Is the windsock.
Yeah, so we know the mast is deployed and everything's looking really good. I still want to see that last image of the rover on the ground. But even if we don't get it, I'm sure that the rover's on the ground because it wouldn't have stopped.
The folks standing there in mission control are really seeing this at the same time we're seeing it.
We're seeing you on
the
CNN,
world is
and your
seeing
viewers and the whole world are seeing exactly what mission control is seeing in real time. Modern television.
This has certainly turned out to be 2 incredibly exciting days that continue to far exceed.
Oh, there's an even better picture of the mast.
Of the mast, again, that's the meteorological experiment. And you can't make out the windsock there, though, can you?
Well, it's just a little off the picture to the left. See, you can just see a little white part there, which is the cone. And what this saying is it's not blowing very hard on Mars.
You can
it's
tell
just hanging
to
there.
the viewers if they were to look to the very extreme left of the picture.
Right.
There
There's a little white bar
bar on the top.
And then there's just a tiny little...
tighter shot of it now. There's a tiny little ball hanging down, it looks like, and that's the windsock. And it's not moving.
It's not moving. And it's not going sideways either. And so one thing you could conclude from that is that this dust storm that's going on in Valles Marineris is not putting very much wind up at our landing site. So that looks pretty good.
It's been a calm day on the surface of Mars.
I should also tell you that the rover May experiment is working. Did Brian talk about that?
No, we did not.
Okay, there's a little experiment on top of the rover solar panel that actually measures the amount of dust that falls on the solar panel. And that experiment is working, and they have measured the amount of dust in the air and compared it with what they're getting from the pictures. And they think that there is some dust leaking over from this dust storm, but not a whole lot.
Oh, so they are experiencing a little bit of dust though, from the dust storm.
But that experiment is working, which is the nice thing about that.
Well, are they getting temperature readings yet?
Oh, yes.
From what have they been getting as
I
far as
don't know.
temperatures
Tim
from Mars?
Schofield will be reporting tomorrow morning. There'll be, I think, the 10 o'clock press briefing tomorrow is a science-oriented press briefing.
But they are now getting readings as to what the temperature is and the wind speeds are and the pressure, barometric pressures.
Weather reports from Mars.
We can start reporting those now on CNN, the weather reports on Mars. Well, they can. The images from the lander are continuing now to show that weather instrument there.
And again, they're going through it with different filters and slightly different positions of the camera. So that's what's going on.
And there would be about 15 or so minutes left, or 20 minutes left, in what was supposed to be about a 40-minute downlink, I believe.
Okay.
This is what they had said.
Let's see what he says.
Yep. The camera deploy time is UTC 091420.
Oh, maybe they're going to try to deploy the camera tonight. Okay, now there's an image. Okay, that's just of the view. See, that's to the right.
This is Mars Pathfinder Mission Control at the Jet Propulsion Laboratory in Pasadena, California. There's a high-gain antenna downlink session underway right now that includes, as we see on NASA TV right now, a view of the landscape. Previously, we were looking at the meteorological mast and two of the windsocks that were located at the extreme left-hand side of the screen, both of them pointing straight up, indicating
Telecom flight. Telecom. Can you tell me how our uplink and downlink powers look?
We can see, Don, in that picture there.
Is minus 121.2.
Nice big fat rock that might be a wonderful target.
It looks again in that one a little hilly area to the background.
Right,
and,
right. Little spiky things in the background.
Now is the camera, the imager is still stowed. It has not popped up yet.
It has not popped up yet.
So for the viewers who don't understand what we're talking about, that means that it can pop up and get in several more feet higher, correct? And start taking higher
right
images.
now is taking images from Mars with its chin.
Images were taken. This is over different
right on the lander's body. But the lander itself is sitting up above the terrain a little bit.
Like dice, dark spots on a white background. Those were magnetic targets.
Right,
there's
the calibration target.
Dr. Mac Dollenbeck said that we'd expect to see, but we also saw the end of the ramp very early in this downlink. There was no rover there, and there was no tracks on the surface. And that was perhaps a wee bit alarming until the realization of the fact that the rover was not just not there yet. The next image showed the rover partially down the ramp into the field of view, and the image after that showed the rover almost completely down the ramp. And of course, the mission support area, as did other areas of the Jet Propulsion Laboratory, erupted when the rover was seen there. We are still waiting. We're probably several minutes away from the rest of the rover deploy images. Literally the world and the scientists are all seeing this at the same time. There's no delay between the NASA television feed and the feed that's being supplied to the mission support area and the science area here at the Jet Propulsion Laboratory. The entire world is watching these images all at the same time.
So while they're doing this,
we'll stand by and go clean with the feed for the rest of this downlink session. This is Mars Pathfinder Mission Control.
Okay, so there was a suggestion we talk about the cameras?
Yes.
Okay, the rover has 3 cameras. The 2 in front are black and white cameras. The one in back is actually a color camera. It's not a very good color camera, but it's still a color camera. And these are little Kodak CCDs, commercial Kodak charge coupled device cameras, just like your little digital camera that you get these days. And their ones in front are actually mostly used for hazard avoidance. And as the rover starts to move in response to the direction that Brian Cooper gives the rover from Earth, she lays these light stripes out onto the ground from lasers, and those cameras see the light stripes. Now, but the cameras are, of course, also good for taking pictures. And so, for instance, a while back, we got a rover picture that showed the ramp still rolled up, not yet deployed. And that picture was taken by the rover's front cameras. Now, there's also a camera on the back that's this little color camera with a very wide angle. And that camera is used, number one, to take pictures of the rocks that the spectrometer is placed on. Number two, to take pictures of the rover's wheel tracks so that we can see what's happening with the soil and how dense the soil is. And then three,
of the rover egressing on the ramp in the next few minutes.
okay, pictures of the rover egressing on the ramp egressing from the ramp in the next few minutes.
You can, just by looking at the tire or the marks of the wheels, you can study the soil. Geologists can study the soil.
Right. For instance, on Viking, when it dug the arm on Viking, which was the last time we landed on Mars, dug into the soil and expected it to be, really fluffy, but it wasn't. It was almost like it was wet beach sand, which is very strange because it's not wet. There was no water in there at all. And then they could see different types of terrain, which they call cloddy terrain and dusty terrain and things like that. And so the nice thing about the rover, we'll be able to roam through these different types of terrain and actually see what they're like. The rover's wheels were widened from the original design to get much wider because we tested it in a sandbox with lunar soil, or soil that was like the lunar. Okay, and so that's what the cameras do, is take pictures of wheel tracks.
All right, well, we can see that they are continuing now on waiting here for these images of Sojourner on Mars. And
okay,
there again
there's another
is
picture
of
the
picture.
scene.
Some local cable operators will be cutting away now for a commercial message, but CNN's live coverage will continue of Journey to the Red Planet.
Have more images arriving.
Again, we see the same image once again of that of the landscape, and as we were saying, it's taken in different filters, correct?
Right, different colors. So.
Well, we've lost our picture here of the...
I hope some viewers are
there it is,
there
it's back.
Okay, it's back. The different colors go all the way from the red end of what you can see to the blue end of what you can see. So this actually has just as wide a range as anyone on. There we go.
There it is.
All right. On the ground. Sojourner is on Mars.
Look at the cheers.
Yeah.
You can hear cheering all over the Jet Propulsion Laboratory here this evening. Go ahead, Rover.
Is that a beautiful sight? Wow.
That is as historic a picture as we may see in our lifetime.
Yeah.
Go ahead, Rover.
We can report visually 6 wheels on soil.
All right.
Right. See that.
6 wheels on soil. There's another one just taking a little... Oh, you can even see a piece of the airbag. See the track?
There's the track.
There's the track.
In the bottom left-hand corner of the picture for our viewers, you can actually see a rover track on the surface of Mars.
The very first Sojourner track. Now, it'll be interesting. I don't know if we're going to get another picture where we'll be able to see the back and see if she's put the spectrometer on the soil or not, but that's what we'll be doing for the evening. And that way, tomorrow morning, we'll know something about what Mars is made out of. Okay, there it is. There's the end of the ramp. She's well off the ramp.
Well off the ramp.
See you later.
So everybody's celebrating like mad in the control room.
If you're just rejoining CNN, you're watching live
Mars
coverage
Pathfinder
of
Mission
Journey
Control
to
at
the
the Jet
Red
Propulsion
Planet.
Laboratory in Pasadena, California. At 10:59.5, the first images came up.
For
on
those
the screen
of the viewers that just got back, just as we cut away, Sojourner is off.
Sojourner is on the surface of Mars, and in this image...
reported that they could confirm that there were 6 wheels on soil.
6 wheels
meaning
on
that
soil.
the rover is successfully on the surface, as can be seen in these pictures here.
You can't see the wheel track in this one very well.
And is on the Mars surface.
But there is Sojourner on the
55
surface
is
of Mars.
DH speed, rest to follow short.
I believe I just heard NASA talking to Houston to pass on to the astronauts that the Mars Sojourner, it's on Mars. Sojourner is on Mars.
This is sort of like one small step for mankind, because
If we can put
Successful
robots
entry,
on
descent,
Mars
landing.
reliably, eventually we'll be able to put
And
people
now
on Mars.
successful
So the
deployment of
astronauts
Sojourner
ought to be
2
real
onto the
interested in
surface of
that.
Mars. This is really the culmination for you of years and years of hard work.
Right.
And the fighting the political budget process as well, and going through a whole new build it cheaper, build it better, build it smaller, build it faster. And you came through it all, and with the team you've assembled, this is the culmination of a dream, isn't it?
That's right. It's absolutely a culmination of the dream. And the real beauty of it is that we put this team together 5 years ago, and then the mother and father of the team were Bill Lehman, who was the chief engineer, who's the world's greatest engineer, and me, and both of us have left. And the team, Jake Matievich and his team, have carried on without a flaw and just pulled it off. I mean, this is a complete team effort of a really brilliant, hard-working bunch of guys. And as is the whole Pathfinder project. I mean, it's not just the rover, but the entire Pathfinder project is just an experiment in how to do everything differently.
What goes through your mind from a very personal sense when you see these images?
Well, this is what I've been waiting 30 years for.
50% increase expected, or?
No, 30 years ago, or when I came to JPL, I wanted to work on a mission to land on Mars. Oh, beautiful. Beautiful. There you can see the wheel tracks.
Are these the three-dimensional?
This may be. I don't know what this is. This is probably Brian Cooper's.
Brian Cooper's.
That's not Brian Cooper, but.
On the right side of that picture a second ago, I thought was Brian Cooper, and.
First pictures of rover on Mars. I don't know where.
Don't forget to call home occasionally.
Rover, don't forget to call home occasionally.
See, these are much brighter now.
Yes.
I think this may be the Ames Research Center experiment. Now, we can't see the antenna. The antenna should be up.
That would be in the, right where basically where the pointer was going, wasn't it?
Right. Okay, I believe this is and there's a little bright spot on the front of the solar panel, and that's the materials adherence experiment. And
there's the celebration.
There's the celebration.
They're
in a striped shirt. In the middle is Howard Eisen, who's the head of the mechanical team for the rover, and Sam Nguyen, who is one of the programmers of the rover. Brian Wilcox in the check shirt, who is the guy who developed the eyes.
Howard Eisen high-fiving there. Yeah. Howard had come out here earlier to talk with us, and I remember having Howard back 6 months ago, back on December 2nd, 2 days before the actual launch, doing a rover demonstration for us at the at Cape Canaveral.
That's right. And, he and I were there on
you were there the same night, a little cold night in Florida.
That was right.
Freezing
to death.
Freezing to death. Not as cold as they are as the vehicle is on Mars, of course. It's a lot colder there. But just a fabulous team.
Here walking toward us is Art Thompson, who is one of the system engineers and one of the controllers for the rover. So practically the whole team is there.
It really enhanced those pictures tremendously.
This is what happens when you get them into these modern computer workstations.
It looks like there's a rock just to the left of Sojourner, doesn't it?
She ran right over. In fact, look, see there's wheel tracks. I think she ran
right over a small one, and then up in the upper left-hand corner where the shadowing is a larger rock.
We ought to be able to tomorrow just turn right around and nail that rock.
Turn Sojourner right there. But tonight, Sojourner will sit right where she is.
And go to sleep.
And put the
spectrometer on the ground and go to sleep.
And start analyzing the soil.
That's right. Now, all night long, the spectrometer will be pinging the soil with little alpha particles and collecting the resulting reflected particles, and that will tell us what the chemicals in the soil are. And that will be all stored on board Sojourner. Now, she has some batteries that she can do this at night because she has primary batteries. That's like flashlight batteries, not rechargeable. And those batteries allow her to work at night because there's not a lot of power drain for that little instrument. The computer will have to stay awake because the computer gets the data. And in the morning, the rover will send the data to the lander and we'll be able to see it here on the ground.
How many scientists do you expect will be crammed into that small room at Building 230, reaching for that data as it pours out on that first downlink?
Well, actually the alpha proton X-ray spectrometer team is very small.
Is it?
Oh, there's only 2 or 3 of them because it's a very inexpensive instrument. It was 2/3 of it was provided by Germany.
for free to us, and the other part of it was provided by the University of Chicago. So there's only a few experimenters, but the whole science team will be very, very interested in the results, because they match that up with the mineralogy, the colors that they get, and the spectra that they get from the lander camera. And it's all going to fit together into really telling us about Mars.
Will they get some very basic knowledge or some basic information right off the bat, or is it going to take them time to analyze what comes back?
It depends. I think if the signatures are very strong, for instance, if there were a lot of iron, which we expect to be in the soil, they should get a very strong iron spectrum. But there may be just sort of trace elements that they may have to massage the data a lot to get it out. If there's something very tiny, they wouldn't be able to see it. I mean, if there's only a tiny amount, because it's just not that strong an instrument. But they'll certainly be able to confirm whether the dirt on Mars is anything like the dirt on Earth, for instance, or whether it's quite different.
Who makes the decision, or has it already been made since... last question, who's made the decision on what rock to go to tomorrow?
Well, the scientists as a whole, they have a process. The imaging team gets to select the rock, and the alpha proton X-ray spectrometer team has an input, and they basically kind of vote, and then one scientist goes and represents to the rover driver, this is the rock we want. And then if the rover driver says you can get to that rock, then that's the rock. The rover driver may veto it and say, look, that's too hard and too dangerous. But I think we can get to that knobby rock right there.
We certainly can. Well, continuing excitement here at the Jet Propulsion Laboratory. Hasn't been a dull moment in a couple of days, and we certainly expect that the excitement will continue. But again here, within the last few minutes, at least on Earth time, it happened a few minutes earlier than that, history has been made. The first autonomous vehicle that humankind has put on another world is safely on that world, on Mars. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena, California.
Yes, John, it indeed has been exciting, and certainly history has been made. Watching all of this unfold live, John, on CNN, along with the scientists who have worked so hard on this. I know this was exciting for you as well. And, John, there is a news conference coming up at 2:30, right?
Yes, there will be a news conference coming up in about 20 minutes, at which point I don't know what they can add to the excitement we've already seen here. But certainly there will be a news conference, and they will explain to us the images and where the Sojourner is and what they plan to do tomorrow. But basically it's time to say goodnight to Sojourner and put her to bed for the evening. The vehicle has performed admirably, as the team has here. And again, as Donna Shirley said, they wait till tomorrow, and then they get that first data back, and then they send Sojourner off to examine the rocks.
All right, John, and we hope to bring that news conference to everyone live. Thank you, John Zarella in Pasadena. And that concludes our coverage for now. And CNN domestic viewers will be rejoining Larry King live, and CNN international viewers, stay tuned. World News is coming your way next.
This has been a CNN Live event.
Live here on CNN, a few moments ago, a space robot called Sojourner rolled down a ramp from its landing craft and began exploring Mars. The command to send Sojourner on its way came from the U.S. Jet Propulsion Laboratory in Pasadena, California. And that's where CNN's John Zarella is standing by now. John.
Leon, just a few minutes ago, within the last 15 or 20 minutes, you could hear the cheers just rising up here at the Jet Propulsion Laboratory from Building 230 and the surrounding buildings here as the first images came back from Mars showing the Sojourner robotic vehicle actually on the surface of Mars. And there is one of the enhanced pictures. You can see it there. Sojourner on Mars, again, history made, the first time an autonomous vehicle has taken some small steps across the surface of another planet. And joining me to discuss this is a woman who is perhaps synonymous with Mars rovers, Donna Shirley, the head of Mars exploration here at the Jet Propulsion Laboratory. Donna, this had to be one spectacular moment for you.
Absolutely. This was just the culmination of 30 years of since I've been at the JPL for 30 years I've been wanting to work on Mars, and here we are. We're on the surface of Mars. And there's Sojourner sitting on Mars. These are the raw pictures that first came back. These are compressed, so they're not real good quality.
There it is off in the distance
there it is,
already.
Off in the distance. Now, oh, here's the movie. There's the movie. It just went down the ramp. Now watch this. 1, 2, 3, bang, onto the surface.
I understand we have...
See the ramp moving around when the rover...
As the rover went down.
So as the rover gets onto the ramp, it actually compresses the ramp down, and off she goes onto the surface.
I understand Howard Eisen is on the phone as well and can hear us talking. And Howard, pretty exciting, heady time for you. You designed... Your team designed that ramp and much of the engineering that went into getting Sojourner where it is now on the surface.
That's right, John, and we are as ecstatic as can be. You've probably seen the shots of us all clapping and hugging each other and everything else.
I saw you high-fiving. Donna and I were standing here watching you high-fiving with some of your compatriots there.
It's been absolutely fantastic. That image of the rover on the ground is something we've all been waiting for 3 years, for some of us 10 years, and like Donna said, she's been waiting 30.
Donna, you weren't there. Unfortunately, you didn't get to share that moment because you are out here with us, giving the world your time, which we appreciate.
We're all on our way down there to hug her now.
Well, I get a lot of hugs later. That's okay. I can have delayed hugs.
Delayed hugs, Howard. What was the emotion going through your mind, Howard, as this was unfolding?
Well, it's a strange thing. We actually got the images of the rover on the ground before we got any telemetry saying that we were moving. So we were all staring at the same TV screen you were staring at, just hoping to see those images. And when we did, it was just unbelievable.
We've been seeing, Donna and I are watching here, and we're seeing the movie where you can actually see the ramp moving as the rover crawls off and puts the weight on the ramp and pushes it down.
That's right. The in your image there, the left side of the ramp is actually sitting a little bit on some airbag material. And so as the rover comes down, that material is compressing and the ramp is moving a little bit. The ramp is very, very light and only tied down at the lander end.
But earlier in the evening, we had seen some of your colleagues working up in the sandbox to make sure, I assume, that all would be okay as the rover went down. So you expected this, didn't you?
Yeah, we felt very good about it, but we figured one more test certainly couldn't hurt if we've come this far.
And again, congratulations to you and your team. And I assume Donna's waiting here for you to come out and give her that big hug, you and the rest of them. But go and enjoy. I imagine tonight will be a night for a great deal of relaxation and...
well, not really.
We have a lot of work to do.
That's right. There's a lot of work to do. They have to plan the next day's activities, and when the scientists pick their rock, they come in, and the rover team has to plan how to go get it.
Howard, we want to thank you for joining us.
Thank you, John.
And Donna, this has been just an incredible night and 2 incredible days. About as heady a 2 days as you probably could have hoped for.
Yes.
How does it make you feel?
Makes me feel great. I feel terrific. I mean, this has been the culmination of a dream, and it's just wonderful. Absolutely wonderful.
Donna Shore, there really isn't much else to say.
No,
Thank you so very much. We can hear the team now. They're coming. Many of the members of the team are coming over here right now.
Yay!
And they're cheering. So, Leon, this is, you can't really say much more. History has been made here at the Jet Propulsion Laboratory. The team is actually going by us here.
Right.
And Brian Muirhead is there. And Wes Huntress,
my boss,
the
Wes Huntress.
Administrator for Space Exploration. And you can see this. There's some fabulous photos. I'll steal them.
No, you don't get them.
From Wes Huntress.
There's your baby.
There's the first actual photos.
I want one.
So, Leon, we're going to toss it back to you now. This is really certainly an exciting event in the history of U.S. space exploration.
All right, Al.
Leon.
Thank you, John. History in the making with some rather excitable scientists there. Stay with us. There's more world news in just a moment.
The following is CNN's coverage of a live event.
We return now to the developing story of the Mars Pathfinder mission. There is a press conference being held now by NASA scientists. We expect to join that right now. As you can see, some rather excited scientists. They, a few moments ago, celebrated the arrival of the Sojourner robot on the surface of planet Mars. Let's listen in to what they're saying now.
And we have the flight team here, and Richard Cook, the mission manager. And Dr. Jake Matijevich, the rover manager. Let's start with some comments from Richard.
Actually, we have the men and women of the Mars Pathfinder flight team. Yeah. There you go. Okay, well, I'm not sure this day has been exciting enough for all of you guys, but I think it has been for all of us. I didn't think we could top yesterday, but it certainly feels that way today. It's been just a great day. The spacecraft is doing wonderful. The rover is on the surface of Mars. We got some great images back and continue to get them back at just a tremendous rate. I know all the scientists are in heaven at this point. So we're really looking forward to getting it on with the rest of the mission, getting the rover out there, looking at some of those rocks, and that'll be what we're going to do in the following days. So with that, I'll let Jake tell you about the rover.
Yeah. Well, it's my distinct pleasure to present to you the first rover on the surface of Mars. The images that you've seen today show a completely deployed rover that has driven down a perfectly deployed ramp and gotten to the surface of Mars, making its first tracks in the soil of this new planet. And to us, it's opening a new era. Yeah, opening a new era of exploration, which we, as in the framework of the Faster, Better, Cheaper, actually starts tonight as we plan our first activity tomorrow on the surface of Mars. So as you've seen this rowdy bunch over here, these are the real heroes of the day who worked, really since last night to solve an incredible set of problems, worked through a number of issues to get us back on our nominal mission. And all I have to say is that's the group that's going to give you the best results that we can possibly do over the next course of the next several days, and hopefully even longer than that on the surface of Mars. So at some point you guys are going to have to meet them all, but in particular you have to meet a few of our rover team, particularly those who are shown wearing insignias of this kind. If you've noticed, in addition to the one image that we showed here of our end of day position on the surface of Mars, there's also a nice little movie that one of our engineers has put together, actually showing the rover deploying down the ramp. And if we can have that movie cued, please, for display here. Yeah. Almost did it, almost did it. Okay, that's actually a movie of our esteemed team. There it is. Okay. As you can see, as the rover drives down that ramp, it moves it quite a bit as it deflects it going down. Finally, it ends up deflecting it for the last time, the ramp bouncing back up again as it deploys onto the surface of Mars. just a terrific set of pictures and a terrific feeling watching these images come down today. So, so we're on to our next day's activity later tonight, and I think that's all I need to say at this point.
Okay. Well, it's been a long and wonderful day, and I know we need to let you get back to work or to some well-deserved rest in some cases, but let's try to get in a few questions here just to wrap things up. Let's see, let's start down here with Matt from AP.
Matt Crenson from the Associated Press. How long does that movie take to transpire in real time?
It's actually, the actual deployment down the ramp takes only about 4 minutes total. It's the rover is actually driving in a move fashion in which it's driving its maximum speed essentially down a 1 meter ramp. So.
Just saw from Justin Mackey, our rover director over there, our film director over there, that it was about 2 minutes. Frames were spaced over the course of about 2 minutes.
So.
Okay, Kelly?
Can you give us a time of when all 6 wheels were on the ground?
We actually get a sketch time down for some telemetry? I don't know.
I think so.
We'll have to get back to you. I'm sorry. I'm not sure of the exact time.
Shall we start a pool?
Seth Borenstein, Orlando Sentinel. Since you went down the back, are you going to use what are your first 2 or 3 targets, and how far off the ramp are you? 5, 6 inches, or what?
The actual move is a total of 2.2 meters from the edge of from the center of the pedal down to the end of the ramp. As you can see, it's approximately about 3/4 of a wheel diameter, which is on the order of about 10 centimeters off the ramp.
William Boyer for Space News. Do you have confirmation that you're doing the soil sampling yet?
I don't know if we actually got that engineering telemetry down. The downlink closed rather quickly after these images were sent. There's nothing to tell us differently that the APXS wasn't properly deployed out on the surface and has already begun taking the first spectra of soil at the rear of the ramp. Try to answer your question a bit here. I missed part of it. The next kinds of targets that we're looking to perform in our experiment sequence include performing a soil mechanics experiment in that general area to get our first measurements of the interaction of the wheels and mobility system with the surface of Mars. And that rock, if you have been following the activities and discussions over the last couple of days, is of high interest to our geology team. So that may well be our first target for an APXS. Okay.
Okay, David Chandler.
David Chandler from the Boston Globe. Can I ask you to do a little 30-second science here? You've got some tracks on the surface already. Is there anything at all you can tell now about the consistency of that soil from what you see?
I think I'll ask our soil mechanics team tomorrow after they've come down a little bit to do a little more careful analysis. It's our first measurement of soil mechanics literally on the surface. But there's other things we plan on doing to expand on that data set, let's put it that way. So we may have an answer for you in another couple days.
Okay, let's see, you'll take one in back here and then see if we can get to Todd there.
Yeah, Jeffrey Kay from Public Television. When do you expect to receive the first images from the rover itself and also the images from the camera from the lander at its fully extended position?
We got our first image from the rover in part of this downlink. This is actually an image we take of the ramp. We're on the pedal at this point, and we're just looking forward to taking an image down that deployed ramp. So that's one of them that we've taken. There's one also of the rear. I'm not sure that has actually come down. There'll be some other images taken from the rover tomorrow of up the ramp that we just descended. Hopefully making a rather nice photo shoot for you to have in your newspapers Monday at the latest. I believe the deployment is meant to occur today.
Yeah, we actually activated the sequence which will deploy the AMP mast in about 2 hours from now. And so actually first thing in the morning we will acquire some images from the deployed position and return them down probably in that first transmit session that we get in the morning.
Todd?
Todd Halverson, Florida today. I was wondering if you could just walk us through what you anticipate the activities for the day will be tomorrow, and when they'll start Pacific time, and what they'll be doing, and when they'll end.
Maybe I could answer the latter part first. The confirmation of what we've done during the day is likely to occur around this same time tomorrow. Nominally after this, about an hour after this downlink closes, we have a series of our team members and scientists meeting in a set of, actually in a group setting to select the goals for tomorrow. I would prefer not to preempt their choice at this stage, but it will be either of these two issues, the notion of attempting to get some soil mechanics experiment, perhaps getting in position to take an APXS measurement of that rock. And it will be in some sequence like that, but I'd like to let that decision be made by the team as a whole.
As far as the lander transmit sessions, the first transmit session is likely to be around 3:30 or so tomorrow afternoon, and then we'll probably have one. I agree with Jake. It's a little bit hard to second guess what planning will go on tonight, but we'll probably have at least one additional transmit session about this time, maybe a little bit earlier tomorrow night. As far as activities that the lander will do, other activities, one of the big plans to do tomorrow is to take what we refer to as the monster pan, which is a set of higher resolution images in multiple colors that are in stereo that we use to plan the future traverses of the rover. And so that'll be certainly a high priority to acquire that. We're likely to also increase our data rate up to about probably 6,300 bits per second, in which case we're expecting to get just a tremendous amount of data down as a result of doing that.
When does the monster pan come down?
It comes down over the course of several days because it's, like I said, in multiple filters, but significant parts of it should come down tomorrow.
Okay, let's see, more local questions. I guess if that's about it, we'll wrap things up. I wanted to make one brief announcement. JPL's web servers have been absolutely inundated with public hits, as you can imagine, and the webmasters asked me to pass on an address that they'd like to recommend for the general public to use. If you find a hard time getting into JPL, the best server to try, I think, is being shown on the screens. It's http://mpf for Mars Pathfinder, www.jpl.nasa.gov. And this is a high-performance system that Silicon Graphics has arranged for, and I understand it should offer a good bet at pulling up the page. And with that, I guess we'll call it an evening, and hope you stay with us for a great mission.
Well, you've been watching a live press conference by NASA scientists at the Jet Propulsion Laboratory in Pasadena, California. Some very excited team members celebrated the successful touchdown of the Sojourner robot on the surface of Mars. It sent back pictures as it rolled down the ramp from the Pathfinder spacecraft onto the planet's surface. As its 6 wheels made contact, history was made. The Sojourner will begin gathering geological samples from Mars, which will last around 7 days. And the scientists were promising that they'll have some more exciting pictures tomorrow. Well, we'll have more on that story and the rest of the Earth News at the top of the hour, but now we're going to join World Sport in progress.
This has been a CNN Live event.
Needed a lift to Mars, and it got it from this spacecraft. Pathfinder carried Sojourner millions of kilometers through space, relayed human commands to the rover, and then took pictures as Sojourner rolled onto the surface of Mars. In honor of another space pioneer, the U.S. Space Agency has renamed Pathfinder for Carl Sagan.
Vehicle is on the surface of another world.
The images that you've seen today show a completely deployed rover that has driven down a perfectly deployed ramp and gotten to the surface of Mars, making its first tracks in the soil of this new planet.
Just as the Martian day was winding down, engineers at NASA's Jet Propulsion Laboratory received the first images of the 6-wheeled rover driving down a ramp and onto Mars.
There it is.
rover, don't forget to call home occasionally.
For the scientists on the team, seeing Sojourner on the ground is a great relief. Now they just have to decide what to look at first.
We have a whole variety of different things. We're already seeing differences in colors, in textures. There looks like there's layering in some rocks. There's that one flat-topped rock, and what are those? We gotta go see them.
It was the culmination of a roller coaster day of anxiety and excitement. Mission engineers spent much of Saturday trying to figure out why the rover and the lander were having a problem communicating. They sent new commands and waited for the response.
We have rover data. Yeah!
Working through the communications problem made it possible to deploy the rover. At one Saturday briefing, members of the science team acted like proud new parents. They unfurled a panoramic picture of the Martian surface. It had taken 5 hours to assemble the 120 tile-shaped images. It was okay to be upbeat. The mission is back on track. 120 million miles away, history is made 2 days in a row. For this team of engineers and scientists, that will be tough to top. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
CNN will bring you live coverage of the latest news briefing by the organizers of the Mars mission. That event is coming up in a little under 2 hours at the time shown here on your screen. The crew of the space station Mir has some good news to celebrate as well. The devices that keep its solar panels pointing towards the sun are working again. The devices suddenly stopped working last Thursday, forcing the 3-member crew to fire thruster rockets to keep the station lined up properly. The trio already has its hands full as it prepares to make repairs to the damaged Spectre module. The crew is awaiting the expected arrival on Monday of a Russian supply ship carrying the necessary equipment. The Progress cargo ship lifted off Saturday from Russia, or Kazakhstan rather. Mir collided with a similar supply ship during a practice docking maneuver on the 25th of June.
I'm Kathleen Kennedy at the CNN Center in Atlanta. We're waiting for NASA to begin its briefing on the latest from Mars. Meantime, this was the scene about 11 hours ago at the Jet Propulsion Laboratory as Sojourner made its first tracks on Mars.
There it is.
The rover's deployment capped off a very tense day at the NASA laboratory. The rollout was delayed by about a day due to a slight landing complication and to communication problems between it and Pathfinder, the main lander. But NASA officials say Sojourner's success puts them a step closer to putting footsteps on Mars.
We will send people to Mars when it's scientifically appropriate, when we could figure out how to do it for a reasonable amount of money because there are other problems inside the nation, when it's safe to go because the International Space Station...
When could you go? If all the money were there, if the will were there, when could you go?
I would say that the first decade of the next century might be possible.
NASA officials were to decide this morning what to tell the little explorer to do next. And for more on that, let's join CNN's Jim Hill, who is standing by at the Jet Propulsion Lab in Pasadena, California. Jim, I can only imagine what the mood was at NASA when they got the wheels in motion. Tell us a little bit about that.
Well, that's right, Kathleen. It's nighttime on Mars right now, and the rover has been sleeping, if you will, right down at the bottom of the exit ramp from the Pathfinder itself. It's on the surface of Mars, and before it went to bed last night, it took its little metal nose and poked it around the ground and presumably now has information, analytical information about the geology of the Martian soil somewhere in its memory bank. Now, later on today, about 5 hours from now, scientists will have an opportunity to downlink that information, and that will give them their first actual hands-on information about the geology of the Martian soil. Also today, they're going to take the rover and give it an order to go to its next target. They've already picked that out. It's a rock that's just next to the rover right now. It's nicknamed actually Barnacle Bill the Rock. And the rover will walk up or crawl up to that rock and put its little metal nose against it. We can show you how that happens. If we can zoom in now on the life-size model of the rover we have here, on the end facing us, you can see the round metal nose-like object. That is the alpha proton X-ray spectrometer. Kind of a mouthful, but what that does is it moves against an object, literally touches it, and then fires off protons. And how those protons are absorbed by the rock or how they're bounced back and so forth can give scientists an absolute wealth of information about the composition of the rocks. So it appears that Barnacle Bill, the rock, is going to be the first target that the rover does this with. And tomorrow sometime, probably tomorrow afternoon, the scientists will downlink that information. It has to be done in this way because the Pathfinder and the rover only operate during the daylight hours on Mars. Sunrise on Mars happens about 2 o'clock Pacific time today, and that's necessary to fire up the solar panels and so forth and get the day's mission underway. It's also necessary for establishing a signal to downlink the information that's in the memory now that was picked up yesterday. So this will be a very interesting day, Kathleen, from a scientific point of view.
So what can they learn from the size and shapes of the rocks that we've seen in some of these pictures?
Mars is interesting to the geologists because, unlike Earth, the rocks on Mars are thought to be, or have been, undisturbed ever since they were formed. Now, on Earth, we have a lot of processes such as wind, rain, ice, snow, earthquakes, the oceans, and all kinds of movement of geological plates that disturb rocks from their natural state when they were formed. Scientists believe that on Mars, none of this has ever taken place, and that the rocks that are now on Mars are very much in the same positions and very much unchanged from what they were eons ago when they were formed. So presumably that means that if you can analyze that rock, you have essentially a textbook of information about the history of Mars. And geology is all about reading the textbook of information contained inside rocks and soil. So the scientists think that they have a very thick textbook of information waiting for them on Mars, and that's why it's going to be so interesting to them to analyze these rocks.
Jim, we also saw some mountains in the distance. First of all, how far away are those, and what can we learn from those?
Well, the mountains that you're talking about are about 20 miles away. The most interesting mountains that they've seen so far are twin peaks. They look a little bit like the humps on a camel, so to speak. And how these formed, why they formed, and what they're composed of is of great interest to the scientists because as you look around the Martian surface, it does look very bleak and barren and flat for the most part. But when you see a large object like that, then something very powerful and something very significant, obviously, took place to form that. So they really want to get over there and examine that, but it's 20 miles away. The rover, from what I understand, can go out 100 yards or so, but a 20-mile trek is probably not possible. But nonetheless, by looking at these photographs and also by looking at information about the rocks that are actually in the area right around the rover, they may be able to piece together information about what those mountain peaks are and how they got there.
All right, Jim, I know you want to get into the NASA briefing, which we're told is beginning right now at the Jet Propulsion Lab. Let's listen in. They're introducing the scientists who are about to speak.
Well, good morning. It's been quite a day for us, as you all know. We have a fully functional spacecraft on the surface of Mars, and we have fully functional instruments in every regard, and as you all know, we have a fully functional rover as well. We were here until about 3 a.m. last night doing the necessary planning in the cycle for deciding what to do on Sol 3 on Mars, which occurs later today, and I'll give you some idea of what those things were. The rover basically is off the pedal. As you are all aware, we sent the command to deploy the IMP after it took a complete panorama in a variety of colors, our so-called insurance panorama, but we did not have confirmation of that until the next downlink, which would occur between 2 to 3 p.m. this afternoon. We have gotten data from the alpha proton X-ray spectrometer, and that instrument appears to be functioning just fine. So now we have data from all the instruments and all the imagers, and everything is working just perfectly. Our plans for today on the surface of Mars are to take our affectionately known monster pan. This panorama is a left-right red stereo pan, which is used primarily as a planning tool for the scientists to decide, finally stereo, so we can measure distances to things and sizes and start giving you some idea of where things are out in the scene and how large they are. But in addition, it's a primary planning tool for the rover. The rover needs this left-right stereo data to ascertain exactly where it is in the scene and to plan its next traverse. And the idea here is to get that down in 360 degrees as quickly as we can so that the rover can put on the stereo goggles and see exactly where they can and cannot go. They plan the paths using this stereo panorama. In addition to the left-right red, we also get a variety of other spectral filters. The idea is to begin to ascertain the colors and some of the spectra of the rocks out in the entire field. We made a decision last night on where to send the rover for Sol 3, and we have decided to attempt to send it to a rock affectionately known as Barnacle Bill. This rock happens to be quite close to the rover, will require a simple turn in place about 70 degrees or so, and a backup motion with the APX down to try to place the alpha proton X-ray spectrometer against this rock. We expect to get confirmation of deployment of the IMP and send up the uplink for the variety of commands that we've been working on through the night at about 2 or 3 p.m. this afternoon, and the main downlink occurs much later after 9 p.m. this evening. The very good news for the scientists here and all of us is that we have decided to double our data rate. We will be returning data at a rate of about 8 kilobits per second, which is unprecedented this soon in a mission. So everything is going absolutely perfectly. With regard to that, we have basically the perfect site, we have the perfect spacecraft, we have the perfect instruments, and we have the perfect rover, and now we're just more excited than you could possibly believe to go out there and start to investigate what's there. In addition, we have in front of us here, and you've all seen the panorama in the back, a view of Mars that we have never seen before. This site is completely different from either of the Viking landing sites. We've been to both of those. We know about the rock distributions at those sites. We know what those rocks look like, their shapes, their forms, their color, their sizes, and we didn't see anything like this at either of those two sites. So those of you that saw those Viking sites that I showed earlier, and you said, well, it looks kind of red and rocky and it all looks the same. Wrong. This place is different. And we hope to start to show you the ways in it's different. And the early indications are that we really do have a grab bag suite of rocks here. It really looks like there are different colors, textures, fabrics, sizes, shapes that are completely different from the Viking and look different from each other too. And we'll begin to show you the data here in just a few moments. In addition, the rock distributions are different. We have many smaller rocks than we ever saw at either of the Viking sites, and we have much more rounded rocks than we had. At Viking 2, the rocks were all extremely angular. We saw no roundedness, and the sizes were all very similar. We have a broad sweep of sizes, very different. In addition, at Viking 1, it took us almost the entire mission to find a dark blue or dark gray rock that was not covered with dust. And of course, as you know, this alpha proton X-ray spectrometer can only see microns thick, maybe 100 or so. And if it's covered with this fine patina of dust, we'll measure dust there. We've measured it at the two Viking sites. We'll measure it all over the planet. It's probably the same stuff. That's not what we want. We want to go to native rock. And the indications are excellent here that we have a wide variety of rocks that are not covered with dust, which is just exactly what we were looking for and very interested in. And finally, nothing could be going finer than the way this mission has progressed up to this date. For comparison, it took Viking 1 about a year to determine where they landed on the Martian surface. We have figured out where we've landed in 1 day. Viking 2 was never able to pinpoint where they came down on the surface of Mars because it had none of those spectacular features in the background, those mountains. And there is real science that we can do with those mountains, and that'll be shown in a little bit by Dr. Greeley. So with that then, I'll turn it over to Peter Smith, who will show you the imaging results that we got yesterday.
Today I'm proud to announce that we have now completed our first panorama of the landing site. And yesterday we showed a panorama with a little bit of a gap missing. 2 frames did not come down on the first day. And the first slide I'd like to show what was in those 2 frames. And later on, can I have the first slide, please? And later on, when you see a panoramic demonstration, these slides will still be missing because our image processing lab here has just not had a chance to include everything in the products they're generating. But this will come very shortly now. This area right here that I'm outlining with the cursor is the data that's in the gap that was missing yesterday. And you can see there's a rather interesting large rock out here. And this is really going to be a wonderful thing to study, I believe. As Matt was saying, there's a wonder to this landing site. It is diverse in exactly the way that we hoped it would be diverse. And we have found hills, we have found a nearby crater several miles in diameter, and one would expect that some of the chunks of rock that were ejected are nearby in our landing site. We see large rocks, small rocks, diverse rock types. Dr. Britt will be showing some of the differences between rocks. We have different soil types. And in the next picture, this is one of the large rocks in the scene and a very peculiar rock on the horizon that's going to be very interesting to study. This is the rock called Barnacle Bill. It's called that because in the close-up view, which you'll see in a little bit, it looks like it's covered with little lumpy barnacle-like features. Now, these certainly are not indicative of life, but they have that appearance. And some of the soils down here are disturbed by the airbags being retracted, and our rover is now right in this position at the end of its ramp. These pictures were taken before the ramps were deployed, and we do not have a current picture yet. We'll be getting that today. Next slide. This is a picture that shows a distant peak right here. If you can see this just peeking over the horizon here, it's rather faint. And this one little frame here has been shifted, and we'll be correcting that in subsequent days. But even so, you do see the distant peak on the horizon here. And of course,